Hello. Hello. Welcome back, everyone. We now move on to other technical sessions of the day. And this session is chaired by Dr. Gnana Prakash, Professor, Department of Physics, Mysore University, and is co-chaired by Dr. S. Chaitra, HPD, BARC. And now we'll have a brief introduction about the chair and co-chair.
The chair of the session, Dr. Gnana Prakash, is currently a senior professor in the Department of Physics at University of Mysore. He has a teaching and research career spanning 29 years with over 300 publications and 8 completed sponsored projects from DST, UGC, DAE, BRNS and others. He served as Registrar of Evaluation, Syndicate member, Academic Council member, Finance Committee member, and Director for Outreach Programs at University of Mysore. He is a recipient of several prestigious awards, including Sir C.V. Raman Young Scientist State Award and fellowships from Georgia Tech, Taiwan's National Science Council, and DAE BRNS. He authored the book Application of Pelletron Accelerator to study total dose radiation effects on MOS and bipolar devices. He has supervised 11 PhD students and is currently guiding 7 more. His academic visits include the USA, the Netherlands, Taiwan, Brazil, UAE, and China for collaborative research and conferences. The co-chair of the session, Dr. S. Chitra, HPD, BARC, is working in Health Physics Division of BARC and has carried out radiological safety analysis of various nuclear facilities in the country. Her area of expertise includes public dose assessment, dose apportionment, discharge limit estimation, and accident safety analysis. She has developed methodology for radiological safety assessment of nuclear power plant decommissioning. She is a member of committees of BARC Safety Council and Atomic Energy Regulatory Board. She has received Group Achievement Award for Safety Studies and Development of Dispersion Models. She is a faculty member of Homi Bhabha National Institute for Radiological Safety Engineering discipline for the course on Radiological Safety Analysis. I invite Dr. Gnana Prakash and Dr. S. Chitra onto the dais, and we are handing over the session to them.
Good morning, everyone. Thank you for the nice introduction of both the chairs. And I would like to thank University of Mysore as well as the committee for giving us an opportunity to chair the session. So now we have an invited talk from Dr. R.B. Oza at RSSD. So he is talking on lessons learned from the consequences of major nuclear accidents. And later we have other presentations from Sanyam Jain, ECL Kaiga EMAD, BRC, that is Decadal trend and seasonal variability of grass beta activity in airborne particulate matter at Kaiga, Karnataka, and also from J. Tulsi Brunda. So she's talking about diurnal variation of 3H activity in air moisture samples at Kalpakkam. S.N. Tiwari is going to present assessment of dose rates to non-human biota around Rawat Bata, Rajasthan through terrestrial route using ERICA. Dr. A.P. Vijit, so he will discuss about behavior of radon progeny and aerosol size radons in the indoor air. Dr. Deepak Kumar, ESL BRC, will talk about seasonal dynamics of grass alpha, grass beta, and beryllium 7 activity in airborne particulates at the NAPS Narora site. And at the end, so we have Dr. P.M. Ravi will discuss about the investigation of ambient gamma radiation dose rates and radon activity concentration in the model house constructed using uranium mill trailing, that biomass, right? I think these presentations we have. Now I request Dr. R.B. Oza, head RSSD, for his presentation. Sir, already you know that you have 25 minutes time, so kindly keep the time up so that we can finish all the
death rate, it is the lowest, and even in terms of carbon emission, when it is lowest, still there is a fear about the radiation. So we just try to analyze some of the accidents and try to see what are the consequences of those accidents in a public domain. Basically, to get rid of fear associated with this energy source. So now I'll just start with Fukushima, and basically I will try to tell what are the lessons we learned in terms of modeling or even in terms of management of the accident. So all those things I will try to cover in this. Now, as it is known that probably in case of Fukushima accident, the activity which got released to the environment or atmosphere was of the order of near about 100 to 120 petabecquerel of iodine and near about 10 petabecquerel of cesium, that is in the atmosphere. And of course, along with this, even FPNGs also got released, and they were in much higher quantity than iodine and cesium. But when we discuss about the doses over a period of 1 year, probably they hardly contribute anything to the dose, and that is why generally nobody discusses about the what are the releases of FPNGs. Now, in case of Fukushima, probably this was the first accident where almost all the dispersion models, they were running in a forecast mode. Forecast mode in the sense that even a priori, people were quite aware how it is going to disperse, in which direction it is going to move, and maybe this was one of the reasons that immediately they could assign the released activity or a deposited activity. They could link it with the period of release, that whatever deposited activities we are getting is due to what release period and because of what weather condition that we have received. Like for example, the most famous is the deposition in the northwest direction, which mainly took place during 14th to 16th March. Now on 14th to 16th March, initially like the activity was dispersing in the southern side of the plant, and then it reversed to the northwest, and probably because of the precipitation and other thing, a large amount of activity got deposited, and that is how it generated that pattern. See, another important factor which came out during this Fukushima accident is that the precipitation, and especially a very low level of rain rate, I will say, that is very, very effective in removing the or scavenging the radioactivity from the atmosphere. So like for example, I have just taken one example from one of the location where, let us say, you have a very high atmospheric concentration of cesium or the air activity, and at that time the dose rate values, which is given by this red color, it is low. Now for many of the monitoring stations, when the rainfall rate, when let us say it is less than even 0.5 mm per hour, it is not recorded many a times. So, like during this period, when you have a air concentration in the atmosphere, they have actually not recorded any rainfall in that region. But based on this visibility and other thing, they inferred that probably during this period, there was a rainfall at much lower rate than 0.5 mm per hour. So, later on, you can see that even though after this event, the air concentration of cesium is practically nil, you have a very high dose rate because of the deposited activity. So, like during this period, you may see that there is hardly any air concentration, but you have significant amount of dose rate due to deposited activity, which you are likely to miss while doing that modeling study to estimate what activity may get deposited, because you have already missed this rainfall event, which is anyway not recorded. So, here the major lesson is that atmospheric dispersion model can effectively help you in like estimating source term, even in defining the areas where you are likely to have impact. And another feature which came out is that the lower rate of rainfall rate is actually very, very effective in removing the activity, and many a times it is actually not recorded or measured. Now, in case of this, almost it is known that more than 90% of the release it took place by 21st March, and another important feature was that almost 80% of the activity it got deposited over the sea. So, even though like atmospheric dispersion models, they can account for reversal of activity under the varying mat field, but in case if you want to have a correct source term estimation, then probably you need to have a proper measurement of maybe dose rate or activity even on a seaside, which even Pradeep sir used to tell even when at the time of accident also. Now, another thing what I wanted to say is that what are the actions they took in public domain. See, it is known that initially on 11th March itself, they declared that within 3 kilometer radius, they have to evacuate the public, and sheltering from 3 to 10 kilometer, and then based on increase in dose rate at the site boundary and other thing, they increase that distance to 20 kilometer, 20 and then 20 to 30 was the sheltering. Now, here basically what I wanted to say is that if you look at the deposition pattern or even a release pattern, actually the maximum release took place on 15th March because of the accident at Unit 2. Now, if you look at their actions or whatever actions they took, on 15th March, when the maximum release was occurring, they were also evacuating people, which was in a way not a correct decision to take at that time, that when a maximum release is occurring, you are removing the people. Another thing what happened is that there were many patients in that area, and on 14th March, they tried to evacuate at least 800 of the patients from the Fukushima area, and they had to do it hurriedly and they could not provide any medical support while evacuating the people, or the patients. Now, out of 800, at least 50 people died, simply because they could not provide proper medical support during that evacuation. Now, at later date, mostly I think after 17, that is during 18th March to almost 21st March or so, when they again evacuate at least 500 or maybe more than 500 patients. But by that time, they were quite familiar with the condition and they could provide proper medical support to those people, and there was no casualty. So, when you evacuate people, or especially the patients, it is very important that you should be in a position to provide medical support, if at all, if you plan to evacuate them. Okay. Now, the unscare, basically they adopted source term provided by different agencies. In fact, at BARC, we also estimated the Fukushima source term. And then, considering whatever countermeasures, like it was given in previous slides, like evacuation and other things, they took into account all those countermeasures, and considering that, they estimated dose to the members of public for different age group and a different special group, accounting for all these countermeasures. And the pathways, as I meant, including all the pathways, and which included even marine exposure also. So, and group what they considered is, group 1 is the people or a population who were evacuated within a period of days to month after the accident. I mean, those people who were evacuated from that area. The second population is, or a second group, is the population in Fukushima prefecture who were not evacuated based on the dose values. Third is the prefecture in the neighboring part of Fukushima prefecture, and fourth is the rest of the prefecture in Japan. Now we can understand that out of all the 4 groups, naturally the maximum dose group 1 people are likely to see, because they were in the close vicinity of the plant. Now for that, when they estimated the dose, in fact you can see, when you estimate it for 1 year period, 10 years period, or even a lifetime dose. So even if you look at the lifetime dose of that population, it was coming to hardly 19 millisievert over the entire life. Now these are all average numbers, or I will say it is 5th and 95th percentile values. So if you are interested in, let us say, looking at the maximum value, probably the maximum value is 2 to 3 times higher than this 20 millisievert. And just to have a comparison, that in case of Japan, their natural background radiation is of the order of 2.2 millisievert, and with that they are likely to get at least 176 millisievert over a period of 80 years or a lifetime. So even compared to what they are going to get from the natural radiation, the dose due to this Fukushima, it was even much less than what they received, or they would have received from a natural sources. Similarly, I have also tried to give what are the doses received by the workers. Now in case of worker, what we can see is the maximum dose received by one worker probably was in the range of 679 millisievert. Otherwise, and it is from almost 20,000 emergency workers, and only 0.8 received more than 100 millisievert. And with time, dose to the workers, it kept on reducing. Now, as I said, that for all other groups, since the dose values are much less than what group 1 people are going to get, so there is no point in discussing about other groups in terms of dose. Now, based on this dose estimation, UNSCARE, they said that even in Japanese population, no discernible cases they are expecting either in worker or even in general public for the cancer cases. That is the final outcome of UNSCARE report, which is published in 2021. Now, based on this UNSCARE analysis and many other papers, we just try to summarize what are the lessons that we could learn from this accident. I think these first 3 I have already discussed, so I can skip it. Even this 4th one, that when you have a lower rainfall rate, which is probably not recorded in your data, but it can be very, very effective in removing the activity. And one has to account for this kind of thing. Another point was that even though you may not have activity at lower elevation, but the activity dispersing at higher elevation can generate hotspots in the areas. And the final point is that though models are extremely useful, as I discussed in the beginning, so models are very useful even for looking at the area which may get affected or what kind of doses it is you are likely to get. But because of the very high uncertainty associated with model, it is invariably done with a conservative estimation. So when you have a model results, you should be very, very careful in communicating those results to the public. So that was another lesson. Another one, that they implemented food ban on 17th March, and that actually reduced the dose to the public. As compared to, let us say, when we look at Chernobyl data or other thing, where the ingestion pathway was significant, if you look at Fukushima data, it is mainly the ground shine which contributes to the total dose. In fact, effectively, if you just consider ground shine dose, probably we can say it is almost covering to the full dose. Another one, based on the other papers, we found that it is thyroid or examination of thyroid. Unless there are some symptoms or if it is really required, that kind of examination should be avoided, because in case of Fukushima, in that area, see, normally in the absence of this Fukushima accident, probably they would have not gone for any kind of a thyroid checking. Nothing might have happened to them, but simply because of the sensitive instrument what they used, they found many cases of thyroid abnormality. So in case of this kind of accident, at least up to some extent it should be avoided. Now the evacuation that effectively averted at least 40 millisievert of absorbed dose and for thyroid dose up to the 500 milligray. That is what UNSCARE says. But as compared to that, the other issues what people faced because of the evacuation. In fact, in case of this Fukushima, the evacuation criteria was like this, that in case if your dose is exceeding 50 millisievert, and let us say even after 5 years of a period, if you are not likely to get less than 20 millisievert, that will become a restricted area where you are likely to have dose in the range of 20 millisievert but less than 50 millisievert. Then that was a deliberate evacuation area where people were evacuated. Even though doses were not that high, it was probably in the range of 20 to 50.
Sir, you have
And-
three minutes left, please. 3 minutes.
Okay, I'll just quickly go through it. So this I will. Another point which came out from Fukushima was the collapse of medical facility, which may lead to other problems in that area. And as I discussed earlier, that evacuation of patients, if at all it is required, it is to be done with a proper medical support, because otherwise, ideally, you should not do that. Now, another important factor, what I would like to say is, in fact, that first point, maybe you can read it. The second point also, see, normally this nominal risk probability, 5% per sievert, what we use, that is a age and sex average probability, and it is applicable for the 0 to 90 years. Now, if we consider only the adult population, that is not elderly population, maybe in the range of 65 to 90, this probability is 0.9 sievert or 0.9% per sievert, which is almost, we can say it is 1/5 of this. So now, even if we accept that at 20 millisievert, you should evacuate people, let us say we agree. Now, in that case, at least for these elderly people, that can easily go up to 100 millisievert per year. So, especially if you want to evacuate elderly people, one should be really, really careful. Either they can allow higher dose rate, if not, then they should provide medical support at least. So, another important factor here was that for existing exposure situation, the criteria is 1 to 20 millisievert. Now, in 1 to 20 millisievert, when you have already evacuated the people, and because of evacuation, they are already in lot of stress. Okay. Now, at that time, if you apply LRA principle, that I should get as low as reasonably achievable, and maybe if you target 1 millisievert and not 20 millisievert, you are likely to create more problem for the evacuated people. That is what just I wanted to say here. There was another suggestion by somebody. Okay, shall I get 1 minute or so?
Anyway, time is over. Anyway, you can finish in as soon as possible.
Yeah. One suggestion, whether it is practical or not, I am not sure. But what one person suggested is that you should try to make use of evacuated people for certain other activities to avoid disuse syndrome, because when people do not have a work, probably they may suffer more. So that was the idea. But now another idea was that, sorry, this in fact, the second point is also actually important, but for the time being, I will just skip it. But ICRP, after this Fukushima accident, they created a working group by that famous person Gonzalez and all, and where I think working group 84 or so, where finally they recommended through ICRP of course, that this collective effective dose, ideally you should make use of this collective effective dose only for optimization purpose or comparing radiological protection options, not for estimating the risk or for projecting the risk. Because what happened is, like in case of one of the Canadian newspaper, they published that because of this Fukushima, in fact we all know that probably in Europe and maybe in other parts of the country also, the activity levels were probably in the range of millibecquerel per meter cube, which hardly can give any dose. But even with that activity, when we estimate dose and multiply it with a global population, it may create a problem. So this Canadian fellow, he said at least 5 lakh more people are going to die because of this. Whereas in fact nothing has happened in Japan also. So the collective effective dose one should not use for this kind of purpose. Then in conclusion, anyway, you know that at least whatever cases we studied, we found that except for the Chernobyl, no radiation related health effects were found in general population. Now in case of course Chernobyl also, we can have much more discussion on that, but since we cannot include it here. But the final thing is that, as I was telling about this nominal risk coefficient of 5% per sievert, and even if I assume that LNT is correct, okay, Oswald sir may not like it, but suppose if I say that LNT is correct, then also to use this nominal risk coefficient for risk projection is definitely not correct. So these are the things I just wanted to share with you. Thank you.
Thank you, Dr. Oza, for a scintillating lecture on consequence of major nuclear accidents. So now the presentation is open for some few, only a couple of questions, only 2 questions, and later if you have more questions you can check later, during lunchtime, since we are running out of time, so only 2 questions are allowed.
Yeah, it is not a question, it is a comment.
Okay.
Very excellent presentation, and in my opinion, this lecture should have been on the first day as a plenary lecture.
Thank you, sir. Thank you, sir.
Number 1. Number 2, what you see and what I have been telling, that radiation protection is a dirty word. Reason is, the number of people they killed in Fukushima, 1,600 people, and the money they spent, $55 billion. It outnumbers if all of them would have been living in the same contaminated zone. That is one. In Chernobyl, more than 1 lakh pregnant women, they have undergone for the abortions for no reason, just because of the LNT model. So, and it is known now that at dose below 100 millisievert, there are adaptive response, where the DNA start repairing itself. Without radiation, even we can't survive. So, below 100 millisievert, making any rules is almost nonsense. Almost nonsense. And we are dictating this kind of rules, regulations, which are not good for humankind. And if despite of Chernobyl and Fukushima, the evacuation, the kind of miserable life we made for the large populations, in my opinion, there should be another forum, which I will always support, where the UNSCARE, ICRP, IAEA, a case should be filed against them in the international court. for making the life of the people very, very miserable and debarring a clean and safe nuclear energy for the mankind.
Okay, so already the first day itself already you pointed out these points. So anyway, thank you for your comments.
Answer.
I like to add some points, especially this will be utilized even to congratulate Dr. Rosa and his team, because when the tsunami report came, before the accident, the emergency control room got activated, and later our Director Health and Safety's room started operating like a control room to assess, and even we were communicating to the ambassador, Indian ambassador in Tokyo, because there were so many people wanted to come back to India. Now I wanted to mention some few points. You might have seen that dose received by the internal exposure or the workers due to internal exposure was very high. Maybe because of shortage of time, he did not highlight. I was lucky enough to talk to the chief radiation safety officer who worked there, plant persons, and I personally recently visited Fukushima on my own money because I had curiosity, I interacted. What was found is, in this emergency situation, thousands of respirators which are used to protect the people from the iodine and other airborne activity were all contaminated. They were all reported to have radiation field more than 10 microsievert per hour. This for the information of my colleagues from IARP. So, but still they were forced to use it because still something is better than nothing. So they were using the contaminated respirator again and again and again. That led to such a big contamination. Then for the colleagues of the environmental monitoring team, since we were taking the data from published data or online data from Japan, we found even after stopping the releases, they found iodine activity in the environment was increasing some location. How we miss it? And this is quite possible. I always tell our ESL people. See, in the center line of the plume, you get always the maximum activity. But when you are monitoring, you don't know when the plume was going, where was the center line of the plume. And you cannot measure in every 1 meter. So the later what happened is in the crosswind direction, they found much higher activity. Now he mentioned about one important thing is that there was a detailed aggressive monitoring for iodine activity in the air and the scanning of thyroid. It was very interesting to find that they found so many people who are having cyst in the thyroid, and even an unscared presentation, luckily I was also there. Those doctors from Japan presented telling that there is cancer even other area. I raised point there. This area, even wind had not moved there, there was no iodine activity in the air or ground detected. So when you do an aggressive scanning in any society, anywhere in the world, you find some cyst. So don't attribute this is due to the Fukushima release, etc. Ultimately, they agreed for it. Now coming to this point, I told finding some radioactivity here and there where we may miss. I want to inform again congratulating Dr. Prabal Chowdhury and his team. The aerial survey system and such system will be very useful. Physically, when you go and monitoring, you will miss many points. But when you scan the area by aerial survey system, you will not miss it. And Japan did not have an aerial gamma spectrometry system like what he and his team has got it. Ultimately, they called the US team. They did the monitoring. Today, maybe after knowing the expertise India is having, USA has offered or they wanted India to become a joint team so that tomorrow something happen anywhere. So you can give a big clap for Prabal and his team who has developed this system. Now, he has already mentioned about the more than 1,000 deaths. Now you understand the position. When a plant, suppose I am sitting or Mr. Adswal is sitting, there is a difficulty for the plant management. You know the plant is building up, activity is bottled up, anytime it can start into a big release. So anticipating a very big release to avoid a very large acute exposure, they were forced to take. They were not God. They had to take a decision. I'm not justifying, but in that condition, they decided to evacuate. But it turned out to be a blunder. Ultimately, everybody put the blame on them. So evacuating people when radioactive plume moving was a very dangerous thing did, and that led to people, heart patients, and even other patients who were ICU, etc., plus member of the public, senior citizen, more than 1,600, if I remember. 1,600 people died. And Fukushima reactor, 2 people died. It is because of the pressure with which the water collided with that on the wall, and people died. There was no death due to radiation exposure. I want to stress this point. Neither in Chernobyl nor in Fukushima. So here,
Sir,
these are
thank
the
you.
important
Actually,
points.
we are running out of time already. 10 minutes past the presentation. So, yeah, please make it quick. So,
Okay, thank you.
if there are no questions, once again, let us thank Dr. R.B. Oza for his interesting talk. So, moment. Okay. So, anyway, so now we will.
We
move on
missed
to
momento.
Okay, sir.
Yeah. Good afternoon to all of you. So now we go to the oral presentations in this session S9 on environmental monitoring and assessment, radiosity for studies on climate change, atmospheric studies. So the first presentation is by Mr. Sanyam Jain. That is a decadal trend and seasonal variability of gross beta activity in airborne particulate matter at Kaiga, Karnataka. So I request all presenters to strictly adhere to the timing, that is 10 minutes given to you. Yeah, thank you. 8 plus 2 it is.
Yes, okay. Thank you. Yes, very good afternoon to all of you. Myself, Sayyam Jain. I am working in Environmental Survey Lab, Kaiga, which comes under Environment Monitoring and Assessment Division of BARC. My work mainly focuses on radiological environmental surveillance in and around Kaiga region. So today I am going to present our decade-long study on decadal trend and seasonal variability of gross beta activity in air particulate matter at Kaiga, Karnataka. I will begin with the introduction section. This is not the complete slide. Some part is missing. Okay, anyhow. As you all know, atmospheric radioactivity mainly originates from both natural as well as anthropogenic sources, which can cause radiation exposure from both internal and external pathways. Since the inhalation of airborne particles, which includes both alpha and beta particles, can pose significant health risks, so it is essential to monitor airborne radioactivity continuously. So in this study, we have presented our decade-long study on gross beta activity in air particulate matter at Kaiga. So before moving ahead, what are the main sources of gross beta activity in air particulate matter? It is mainly originates from natural as well as anthropogenic sources. Under natural sources, it is mainly comprises of radon and thorium progeny. And under radon progeny, it is mainly the primary contributors of gross beta activity are lead and bismuth isotopes. For example, lead-210 having the half-life of 22 years and bismuth-210 having the half-life of 5 days. These are the primary contributors in gross beta activity as compared to their other isotopes of lead and bismuth having the half-life of few minutes only. And in case of anthropogenic sources, it includes nuclear activities such as power plant operations, nuclear weapon testings, and major nuclear accidents like Chernobyl and Fukushima. And it can also be emitted from the industrial emissions as well. So this was the first part of my introduction section, in which we discussed about the major sources of gross beta activity in air particulate samples and why its monitoring is essential. In the second part, I will briefly highlight the time series analysis method, how to use and in analyzing the long-term trends and characterizing seasonal variation in gross beta activity levels. Time series data simply means collection of data points recorded at regular intervals over time. Though there are many methods of time series analysis to study these trends, decomposition of time series is one of the method, in which decomposition process is a statistical method in which the time series is decomposed into its different components known as trend, seasonal, and random. Among these, there are many methods of decomposition of time series: classical decomposition, X11, seeds, seasonal extraction using ARIMA, STL, seasonal and trend analysis using LOES, etc. Among these, classical decomposition is the most earlier developed or the simpler one. It has two forms, additive and multiplicative. In additive model, the components of the time series can be represented with the addition of all of these, And in multiplicative, it can be represented with the multiplication of trend, seasonal and random components. So with this introduction, I will move ahead with the materials and methods used in this study. First of all, air sampling. Of course, the air particulate samples were collected using glass fiber filter paper at ESL Kaiga using vacuum pump at a flow rate of 50 liter per minute. And the total volume of air sample is 144 meter cube in our weekly sampling. And finally, the gross bit activity was calculated using the low background or low level background plastic scintillator based beta counters. So now we have the weekly data of 10 consecutive years in this our decade long study from 2011 to 2020. The data was aggregated into monthly averages for study the seasonal variation or the monthly variations. And the resulting time series were decomposed using the seasonal decomposition using the decompose function from the stats library package of R software. R is an open source and freely available software that is mainly used for statistical analysis. And finally, the long-term trend analysis was carried out using the man candle or thin sense slope method. Man candle is a non-parametric test mainly used for monotonic increasing or decreasing trend in the data. And thin sense slope gives us the rate of change or the magnitude of trend in the data. It is also a non-parametric method and is calculated by taking the median of all possible slopes between the pairs of data points. So let's look at the results. Okay, complete slide is not there. Yeah, in table 1, statistical summary of gross bit activity, we can see the total number of sample was 510 in this decade long study, and which ranges from 0.2 to 3.1 millibecquerel per meter cube with GM of 0.5 and GSD of 1.9. And we can see from figure 2 the distribution plot also. It is distribution of gross bit activity. It is positively skewed having the skewness value of 1.5, which tells us the asymmetry in the data, and kurtosis, which tells us the peakness of the data, value of 3.5, indicating a non-normal distribution of the data. And of course, the activity levels are very less with the GM or the arithmetic mean of 0.7. It indicates that this is mainly because of natural background levels or of the order of natural background levels only. And all these samples are simultaneously also subjected for gamma spectrometry analysis, and no reactor originated radioisotopes was identified in this sample. So it further confirms that it is of the orders and the natural background levels only. So next part is our decomposition. In figure 3, we can see the time series decomposition of monthly gross beta activity at Kaiga. As I discussed in introduction section, it decomposed into 3 components are observed. Then first component after decomposition is trend. Trend component is simply decomposed by taking a moving average of the original time series data. Then after the trend component is extracted, seasonal component is estimated either by subtracting of the trend component or by division. It depends which model we are using. In additive model, it is calculated by subtracting the trend component from the original time series and taking the average. And this seasonal component is also known as seasonal factor or the seasonal index that we have estimated in this study. And the random component after remaining component is also called as irregular or noise component. After the trend and seasonal, what remains, it comes under random component. So in table 2, we can see the monthly seasonal factors are represented here. Here we can see from June to September using additive model, the seasonal factor was negative, and in other months it was positive. And during June to September, there is monsoon season in Kaiga, and this is mostly because of wet deposition and radioactivity of gross beta activity in air particulates decreases. So if we are using multiplicative model, it is less than 1 during monsoon period, and during the drier season it is greater than 1, which mainly because of drier conditions, resuspension can be the one of the factor. Finally, the long-term trend. As I earlier said, the data was deseasonalized by removing the seasonal component, and the long-term trend was estimated using man-candle test, and the results are presented in table 3. We can see when the p-value is less than 0.05, because we have used the significance level of alpha is equal to 0.05. If the p-value is less than 0.05, null hypothesis is rejected, which indicates that there is no trend, and alternate hypothesis is true, which indicates either monotonic, increasing or decreasing trend. So from p-value and z value greater than 1.96, if the modular of z value is greater than 1.96, it indicates either a decreasing or increasing trend. So in our data, it was a decreasing trend in gross beta activity. And finally, the sense slope was minus 0.03. If sense slope is negative, it indicates decreasing trend. If it is
Your
positive,
time
it
is up,
indicates
no?
increasing trend. Yes, sure, ma'am. So it indicates that the overall during the decade, gross beta activity has formed in the decreasing order. Finally, the conclusions, the gross beta activity ranged from 0.2 to 3.1 millibecquerel per meter cube, and it was mostly around 1 millibecquerel per meter cube and within the natural background levels only. This decade-long study demonstrated the significant seasonal variation in gross beta activity with the lowest level observed during the monsoon and highest during the winter season. These findings underscore the importance of considering seasonal effects in assessment of airborne radioactivity. With this, I will conclude my presentation. Thank you for your kind attention.
Thank you, Sanyam. I think questions, one, but is there a couple of questions? Okay, I think we can move to the next presentation.
Yes,
Okay, that is, next presentation is by Tulasi Brinda on diurnal variation of tritium activity in air moisture samples at Kalpakam.
Need the pointer. Next slide. Good morning, all of you. I am Tulasi Brindra from ESL Kalpakam, and my paper is diurnal variation of tritium activity in air moisture samples at Kalpakam. So this is just a representative picture of Kalpakam multi-nuclear facility, wherein we have got IG car with FBTR and allied facilities. Then this is nuclear recycle board. We have this car, this Kalpakam reprocessing plant, waste immobilization plant, and centralized waste management facility. Then mainly this Madras Atomic Power Station consisting of 2 units of PSWR 220 megawatts. Then in other the projects under construction is Bhavini, PFBR, and FRFCF, fast reactor fuel cycle facilities. So for all this, environmental surveillance at Kalpakam. So low-level radioactive gases and liquid waste generated from these nuclear facilities are discharged to atmosphere through Stack and Bay of Bengal, within the stipulations laid by the regulatory authorities. So regular environmental monitoring program is in place at Kalpakam, which is carried out by Environmental Survey Laboratory, EMAD-BRC. So in one of this, tritium as H2O is a major radionuclide in gaseous effluent, which is a soft beta emitter and is having a half-life of 12.34 years, and pure beta emitter with a Emax of 18.6 keV. So during our normal environmental monitoring, we split into up to 30 kilometers. Different sectors, we go and collect the samples and analyze in our laboratory. So for normally materials method, in routine air samples, we go for this ice condensation method, which is literally a grab sample method. So that is, we keep for a tumbler of ice and collect for 20 to 30 minutes the moisture, and then we analyze using a liquid scintillation detector. The counting time, the MDA for tritium in air is around 0.06 becquerel per meter cube for a counting time of 200 minutes with sample volume of 10. So for this, we wanted to study, generally we get a grab sample only. To study a diurnal variation, we needed an instrument. So this is an automatic air moisture collection sampler using thermoelectric cooling technology, designed and developed by ESL Kakrabar, which is very useful. So this is one 24-hour one is a 24-hour sample in which we have 24 bottles. We can adjust the times for each hour. Moisture is collected. Other is a cumulative air moisture sampler for 24-hour samples. So we had to first find a location to study the diurnal location. So we had taken the previous 3 years record. We found in the quarterly windrows that generally windows flowing towards WSW when in the month of October, November, December. So we had selected a point in WSW sector. We need a power point also for keeping this instruments. So in that way, we selected on 1.5 kilometers FRF-CF gate. We selected the location. So for 3 consecutive days, we had placed both the collectors, atmospheric collectors, and we measured the tritium activity. So if you see for day 1, the minimum was 0.17 to 52.95 becquerel per meter cube. Day 2, it varied from BDL to 12.73. On day 3, it was 0.07 to 28.05. The mean values were around 11.02, 2.31, and 5.01. So on the same days, we had collected the cumulative air moisture collection also, which gave a value of 12.99, 3.05, and 4.65. In addition to this, normally we do this ice condensation method. So in that sample, we got a value of 13.85 becquerel per meter cube. Then on these 3 days also, we tested the windrows. So whether we are doing that correctly, the air was flowing in this direction. We could see that 15% of the time the air was flowing in this direction where we had kept the samplers. So, and this is the diurnal variation of 3 days. What the pattern which we could observe was around 80% of the samples were less than 5 becquerel per meter cube. In otherwise, generally we observed 2 peaks in a 24 hours period. One was during that maybe the 21-30 hours to around 3 hours. Then other was during the next morning time, in the afternoon time from 10:30 to 13:30 hours. But generally it was very low. Maybe from 4-5 points we are observing little bit high activity. So this may be due to the wind may be flowing in this direction. So just a conclusion, tritium activity in air moisture samples was measured using hourly and cumulative automatic air moisture samplers. The study indicated that the activity levels were low and comparable with other NPP sites. We compared with the other sites, and it was same as observed in our listing. So this study can be further, we are planning to do in different directions and different distance so that we can back calculate the dilution factors. Thank you.
Thank you, Tulsi, for completing the presentation quickly and time. So we have time for a couple of questions from the audience. Anyone? Any questions? Okay, no question. I can ask one question, I think so. Like, have you correlated these measurements with the discharges from the plant, MABS 1 and 2?
Yeah, MAP stack, we try to correlate with the annual dilution factor. It was quite less. That is why we are using measurement. We wanted different places. We are going to correlate with that. Now, presently with this alone, we are using an annual dilution factor. We are not able to correlate.
Okay. The discharges also you have correlated, yeah?
Yeah, at stack discharge.
Okay, thank you. So we move on to the next presentation, that is by S.N. Tiwari, and it is on assessment of dose rates to non-human biota around Rawatbhata, Rajasthan through terrestrial route using ERICA software.
Just. It is not coming, huh? Okay. Good afternoon, respected chair, co-chair, and my august audience. First of all, I will thank that IARP to give me an opportunity to present this work at that IARP forum. And secondly, I will thank to my all seniors and mentors who had nurtured and motivated in the field of radiation protections, so that we had gained sufficient knowledge regarding radiation protections. And regarding myself, I am S.N. Tiwari, working in Environmental Survey Laboratory at Rawatbhata, Rajasthan site. This Rawatbhata, Rajasthan site in-houses 5 operating nuclear power plants. And in addition to that nuclear power plants, 2 units of 700 megawatt electric unit are also upcoming at this site. And one plant catering to the requirement of fuel bundle requirement of the 700 megawatt nuclear reactors. Nuclear fuel complex is also being in the phase of operation in the coming 1 year actually. And heavy water plant also is there, though it can be categorized as a some sort of chemical plant. So normally at ESL RAPS, our main mandate is to evaluate the dose to the public or the representative person at the site boundary. So in this study, we try to evaluate the dose to non-human biota due to the natural radioactivity present in the environment of Rawatbhata, Rajasthan site. And it is a part of the radio ecology study. And of course, it is a very challenging field because for example, that flora and fauna living in the vicinity of the nuclear power plants, there may be synergistic effects also due to that radiological releases and the other environmental stressors, which can increase the dose effect relationship in case of the non-human biota around the nuclear power plants. So the part of the assessment, that impact assessment of the ionizing radiation on non-human biota is also gaining importance because the radiation protection aspect and the dose deliver mechanism of the humans is very well understood using the concepts of radiobiology. But initially it was thought that if the radiation protection program is being implemented and suppose it is scattering or it is meeting or it is keeping the human safe, then it was considered that the flora and fauna living nearby are also safe with this implementation of that dose limits actually. But now it is being understood that the dose delivery mechanism or the mechanism through which the radionuclides are incorporated into the flora and fauna are having variations as compared to the human, and hence there may be some gaps in that evaluation of dose to the public residing nearby and the living flora and fauna or non-human biota living in the vicinity of the nuclear power plants. So just to have the study, one to that baseline study of what exactly the status at the nuclear power plant of Rawatbhata site, we evaluate the radiological risk to non-human biota utilizing the ERICA tool. So ERICA is an environmental risk from ionizing contaminants assessment and management. It is a tool developed using that Euroatom project and the FACET program. And it is a specialized dosimetric tool to determine external and internal dose rates to non-human biota developed as an outcome of Euratom project. So this present study, it evaluates the radiological risk to non-human biota due to the presence of natural radionuclides of uranium-238 and thorium-232 and that fallout radionuclide of cesium-137. The Rawatbhata Rajasthan site is surrounded by the forest areas of Mukundra Hill and the Dara, and it is the homeland of various flora and fauna species of tropical forest and the semi-arid forest climatic region. And the screening dose rate criteria of 10 microgray per hour was adopted based on that ERICA model. Of course, that US DOE has their separate limits for terrestrial and aquatic habitats. And dose rates below 10 microgray per hour were assumed to have negligible potential risk or no adverse effects on the non-human biota. And using the tier 2 approach, the tier 1 approach, only that environmental media concentration limits and the concentration ratios are being evaluated using that ERICA approach. But when we are using the tier 2 approach, in addition to that environmental media concentration limits, that external or internal dose and the risk coefficients are also being evaluated. So we collected the soil samples around the offsite domain of that Rawatbhata Rajasthan site. Almost 65 to 70 samples were collected, and they were contents of cesium-137, uranium-238 and thorium-232 were evaluated as per that gamma spectrometric technique. And then the various phylum of that non-human biota were considered for evaluating the dose to the reference organisms of that phylum Amphibia, annelid, arthropod, birds, mammals, large mammals burrowing, lichen and bryophytes, and reptiles. And then inputs to dose assessment model include that radionuclide activity concentration of cesium-137, uranium-238, thorium-232. Of course, the progenies of uranium and thorium has not been considered. And then the concentration ratios in the reference organisms and the radiation weighting factors of around 10 for alpha. For low beta energies, radiation weighting factor of 3, and the other beta and the gamma radiation weighting factor of 1, and the dose conversion coefficients. And the assessment included the calculation of external dose rate, internal dose rate, total dose rate, and risk coefficient for each reference organism. So that average specific activities of radionuclides in the soil samples varied from 0.4 to 2.2 for cesium-137, from 14 to 37 becquerel per kg dry weight, and for that thorium 21 to 62 becquerel per kg dry weight. That almost 7 years, 2016 to 2023 data were used, and that each year data were used to evaluate the reference dose to that non-human biota. So we had carried out annual analysis, and the maximum activity concentration, it was found that the maximum activity concentration of uranium-238, thorium and cesium was found in lichens and bryophytes. And the reason is that they are having high concentration ratios in the ERICA tool, which has led to that elevated activity concentrations. And then maximum dose rate per organism to various reference organisms varied from normally 8 microgray per hour to 1.4 microgray per hour. And then greater accumulation of radionuclides due to slow growth rate, presence of waxy cuticles, and the specialized structures for water and gas exchange, lichens and bryophytes, they receive highest dose, and that's why they are the, and moreover, they are due to that specialized mechanism, they are the what's called receiving the higher dose when we are carried out in our study actually. And then annelids showed the lowest activity concentration from cesium-137. Amphibians exhibited the minimum activity for uranium-238, and the mammals showed minimum activity for thorium-232. The variations may be attributed to the variation in their habitat, occupancy factors, and concentration ratios. And among these radionuclides, external dose rate is maximum due to thorium and the cesium-137. However, maximum internal dose rate was associated with uranium-238 followed by thorium-232. And all assessed dose rates remained below the ERICA standing level of 10 microgray per hour. And the order of radionuclides contributing to dose is uranium-238, then thorium-232, and then cesium-137. And the risk quotient values for all reference organisms were less than 1. That is risk quotient less than 1. So the conclusion, the background radiation dose rates due to cesium-137, uranium-238, and thorium-232 for non-human biota in the terrestrial environment around the Rawat-Bhatta, Rajasthan is found to be lower than the ERICA screening level of 10 microgray per hour. And the total dose rate was dominated by the internal one due to the contribution of naturally occurring radionuclides. And the values of risk quotients were significantly less than 1. And the terrestrial flora and fauna of the Rawat-Bhatta are minimally exposed with negligible risk from the radionuclides studied. And thank you.
Thank you, Tiwariji, for completing in right time. So now the presentation is open for a couple of questions. Any questions from the audience?
Just I would like to ask the question. It has been studied for the naturally occurring only cesium-137 fallout.
Yes,
So,
it can be considered as a baseline study for that Rawat-Bhatta site. But of course, it is a part of the series of studies which we are going to carry out, and then overall impact of that anthropogenic radionuclides, and also will be studied
so anyhow, they are naturally present. So the risk to the animals are like they will be there actually. We can say from the plant anyway, no contribution is there, and then the levels will be quite lower than that.
Yes, yes.
Yeah, Tiwari, one more question. Is there any specific reason for keeping potassium-40 out of the study? Is it an exempt nucleide so far as this non-human biota is concerned?
No, normally that ERICA model, that Tier 2 approach, normally that K40 they had not considered for that dose assessment. So that's why it was not considered. But however, it can be added, and it can be that added to that what's called dose assessment methodology.
Okay.
Okay, if there are no questions, once again thank Dr. S.N. Tiwari for his interesting talk.
So thank you.
So next talk is from A.P. Vijit from Bangalore University. He is going to discuss about the study of continuous behavior of radon progeny and aerosol size fractions in the indoor air.
No. Good afternoon all. I'm extremely happy to be here and to present my research in front of such a great scientific community. And I thank IARP to provide me such a great opportunity. I am Vijit AP, research scholar of Center for Advanced Research in Environmental Radioactivity, Mangalore University. Here I would like to talk about my study of continuous behavior of radon progeny and aerosol size fraction in indoor air. So before I start my talk, I would like to recall a small point that yesterday Professor Y.S. Maya, he was quoting in his talk that radon and progeny is an evergreen subject. So the studies or the scientific community is concerned about radon and thoron from long back, and still the concern is as it is. So it's a hot topic. So here I would like to present my research on radon progeny. As you know, radon and its progeny are recognized as important contributor to natural radiation exposure in human habitat, that especially in indoor air and outdoor air. So lot of environmental parameters are influencing this radon and its progeny concentration, and in that the aerosol size fraction concentration is one of the most important. Upon formation, the radon progeny will attach with aerosols, and due to the and it will lead to the formation of radioactive aerosols. And due to the long-term like suspension and long-distance transmission capabilities of this radioactive aerosols, especially these dust particles, particular matters, that will cause that will be contributing to the radiation exposure in more aspects. So here, my study is a continuous monitoring of radon progeny distribution, and I would like to correlate that with the particulate matter concentration. So as I discussed before, the radon is a hot topic, so that there are large number of studies on radon. So there are a lot of studies have already took place about radon, but the progeny concentration measurements, continuous measurements of radon progeny, and correlation of that with environmental parameters, especially the particulate matter concentration and its behavior, is very limited. So the present study is to identify the correlation of particulate matter concentration and its behavior to the radon progeny concentration. It's a continuous study, continuous monitoring study. So the materials, the major instruments I used for this study is the AlphaGuard PQ2000 progenitron for continuous measurements of radon, and this measurement was done in a 60-minute cycle for 120 hours. And the radon progeny concentration were measured using the Tracer Lab working level monitors for radon progeny measurements, and the particulate matter concentration was measured using APT continuous aerosol monitors, applied particle technology monitors. So I measured radon progeny and the aerosol concentrations in a continuous manner, and the indoor concentration of radon gas was ranged from 21 plus or minus 9 becquerel per meter cube to 137 plus or minus 21 becquerel per meter cube, with an average of 59 plus or minus 14 becquerel per meter cube, while radon progeny concentration range from 1 plus or minus 0.1 becquerel per meter cube to 20 plus or minus 0.6 becquerel per meter cube, with an average of 6 plus or minus 0.3 becquerel per meter cube. Similarly, as I discussed already, I have continuously measured aerosol concentrations, especially PM1, PM2.5 and PM10 concentrations, and the mass densities variation was from 20 microgram per meter cube to 112 microgram per meter cube, with PM1 concentration ranging from 20 microgram per meter cube to 65 microgram per meter cube, PM2.5 concentration from 27 microgram per meter cube to 104 microgram per meter cube, and PM10 concentration of 30 microgram per meter cube to 112 microgram per meter cube. I will explain it detailed once again. So the radon, this is the radon and progeny concentration continuous monitoring. The result is this. So the radon and progeny concentration, as I discussed, the concentration was ranged from 21 plus or minus 9 becquerel per meter cube to 137 plus or minus 21 becquerel per meter cube. And the other interesting observation was the variation, the diurnal variation. The diurnal variation of radon, as like already reported by various researchers, we also observed the same, like the radon concentration was higher during late night hours and early morning hours, and it was less during the daytime, like especially in the noon hours. And we have observed a similar trend for the progeny concentration also. The progeny concentration was higher during the late night and early morning hours, whereas it was less during the daytime, especially in the noon. And the aerosol concentration measurements was also continuously done, and almost a similar trend was observed. The figure 4 represents gives PM1, PM2.5 and PM10 concentration variation, whereas PM2.5 concentration is separately given in the figure 3. So here also we observed a similar trend as similar to the progeny concentration. So here I just try to correlate the progeny concentration variation with the particulate matter concentration variation, and we have observed a positive correlation, and the progeny concentration was peaking where the particulate matter concentration was peaking, and it was less when the concentration of particulate matter was less. So we observed a positive correlation of progeny with particulate matter concentration, and I have done statistical analysis of that, and the Spearman correlation coefficient was 0.7. It gave a strong correlation. The radon progeny concentration was correlated strongly in a positive manner with the particulate matter concentration, and with a 95% of significance. And as I already discussed, we observed a very good temporal variation we observed a diurnal variation of progeny and particulate matter also in a positive manner. So the diurnal variation also give an idea that the progeny and aerosol concentrations are also influenced by other environmental parameters. So my conclusion is the indoor radon progeny concentration exhibit a strong dependence on particulate matter concentration and with the ambient environmental parameters, and this will this is a lead to my upcoming studies, and I would like to study more about the dependency of radon progeny with the particulate matter concentrations. Thank you.
Thank you, Vijit, for completing the presentation at right time.
Thank
so
you,
now there is time for a couple of questions. Any questions from the audience? If there are no questions, let us move on to the next presentation. That is from Deepak Kumar from ESL BRC.
Thank you so much.
So he is going to discuss about seasonal dynamics of grass alpha, grass beta and beryllium 7 activity in airborne particulates at the NAPS Narora site.
Good afternoon, everyone. My name is Deepak Kumar. I am working in ESL NAPS Narora. NAPS Narora having a site having 220 megawatt twin unit of PSWR tape reactor, and ESL lab is doing the environmental surveillance around the site during the operational phase of that reactor operation. During my presentation, a topic is seasonal dynamics of gross alpha, gross beta, and beryllium-7 activity in airborne particulate at the NAPS Narora site. We will go through the presentation includes our introduction and objective of the study, meteorological condition observed during the study period, material and method, and result and discussion. Atmospheric radioactivity arises in the atmosphere due to the decay of the natural radioactivity present in the earth crust. Cosmogenic production of radionuclide is due to the cosmic ray interaction of the nuclides present in the atmosphere and human activities. Our key focus during the presentation will be gross alpha, gross beta, and beryllium-7 activity present in the atmosphere and attached to the aerosol particles. The monitoring of the particulate in air matters is important parameter at any nuclear facilities, and we are monitoring that air particulate matter continuously and to detect the release peaks due to the various nuclear operations. Objective of my study is to analyze the seasonal variation influencing by the meteorological elements on atmospheric activities. Study period is 1 decade from 2014 to 2023, and study site is NAPS Narora. Meteorological condition observed during the study period of the site: summer season observed during April to June mid, and monsoon started from mid of June or last of the June to September, and winter season observed during November to February. Predominant wind direction observed northwest and southwest, and annual rainfall observed during the site is 700 to 800 mm. Atmospheric condition considered during the study is rainfall, relative humidity, and air temperature. Air particulate samples were collected at the site on continuous basis for 24/7, and the samples were collected on a glass fiber filter paper, and weekly cumulative samples were collected on the filter paper and kept in the desiccator to remove the moisture from the sample and decay out the short-lived radioactivity. After the decaying out the short-lived activity and the removal of the moisture, the sample were weighed to find out the particulate matter concentration in the air, and later it was counted in the gross alpha, gross beta counting system to find out the concentration of gross alpha, gross beta. And cumulative sample of 4 to 5 weekly samples were counted in the monthly basis in the high purity germanium detector to quantify the beryllium concentration in the filter paper. Seasonal variation of radioactive concentration. From the study results, we observed that the higher activity were observed during the summer season of gross alpha and gross beta, and lower during the monsoon season. And in case of beryllium-7 concentration, it peaks observed during the spring and summer season and lower during the monsoon and the winter season. The main cause of this seasonal trend, because during the summer season, the animation of the gross alpha and gross beta, that is the progeny of the radon thoron gases, increases, which results the concentration higher, and due to the more wind speed and resuspension of the particulate matter, that this radioactivity get attached to the particulate matter and observe higher concentration. Whereas in case of beryllium, what we observed that beryllium produced in the stratosphere and it get transported to the troposphere during that spring season, and that from the spring season we observe that transport from the troposphere to the earth surface due to the high convective conditions which result higher concentration in the surface of the earth. And during the monsoon season, both the beryllium and gross alpha, gross beta activity were lower because due to the wet fallout of this activity. And in the winter season, due to the non-availability of this activity in the atmosphere, result lower activities. Meteorological influences. The meteorological conditions influence this activity in the atmosphere. We did the Pearson correlation study and found that the relative humidity and rainfall are negatively correlated, which suggests that effective and wet deposition during the monsoon season. And the air temperature is mild, positively correlated, and total suspended particulate matter is strongly correlated, which indicate enhanced vertical mixing during the warmer month. Result of the study, we observed that gross alpha, gross beta, and beryllium activities show clear seasonal pattern, peaks in the April to June and low values during the monsoon and winter. Meteorological factor affecting this seasonal variation is air temperature, relative humidity, rainfall. Significantly influence the airborne radioactivity level. Wet deposition during the monsoon reduce the radioactivity, while warmer month enhance the vertical mixing. Conclusion. Meteorological factor play a very important role in the seasonal variation of the airborne activity. Monitoring this variable is essential for understanding and predictive radioactivity level in the environment. Data is crucial for predicting modeling of airborne radioactivity, help in the environmental protection effect near nuclear power stations. Further study needed to refine the predictive modeling using the long-term meteorological data collection and radioactivity data collection. Thank you very much.
So now the presentation is open for discussion. So any one or two questions from the audience?
I would just like to ask you how these studies, can we use it for making some more realistic prediction on the dose assessment?
We have to increase the data collection and the study, and we have to do regression analysis to make the this study in predictive, to predict the radioactivity, atmospheric radioactivity by the measuring the environmental parameters.
Thank you. Thank you.
Thank you.
Okay, so now we move on to the last oral presentation in this session, that is by Dr. P.M. Ravi sir. It is on biomass methodology for radiological environmental impact assessment.
Thank you. I have to use this no? For yeah. Good morning to everybody. I think good afternoon to everybody. Yeah. So this theme of this conference, that is radiation protection for sustainable nuclear energy, adapting to climate and technology changes. This theme prompted me to discuss, rather share my views on this sustainability issue of which covers, of course, nuclear power plant also. So, what is sustainability? See, the UN, the United Nations, in one of its meetings, proclaimed about 18 goals for it is called Sustainability Development Goals. And these industries which are going to come up in future, they are supposed to support these sustainability goals so that we have a sustainable earth in future. So as you know, the nuclear power is a low carbon source of electricity, and it supports one of the major sustainability goals, that is the mitigation to climate change. But that is not enough. We have to support other goals also. So a proponent of nuclear power is supposed to ensure that the other goals are also met with while designing or operating a nuclear power plant. So that involves the various components. Like, actually in this presentation my idea is only to just put forth the subject, and the sustainability is a very complex issue, and I will not be going into details of that. The idea is to put forth this in front of this audience, especially youngsters in my colleagues of, rather ex-colleagues of Department of Atomic Energy, as well as students, so that they can take further and do more work on this area. So, as I was telling, this economic, social and environmental aspects are very important in deciding the sustainability part of it. And even in our nuclear power regulations like ALARA, that also is has already considered this aspect, that because any optimization of radiation protection should take into account social and economic aspects into account. In fact, we have forgot many of this, we ignore these social and economic aspects when we talk about ALARA. That, I think that is a major reason of why all these controversies, like, no, this is good, this is bad, and all those things. So once, if you are, no, but I can understand the difficulty involved in accounting the social and economic aspects, because it is very complex, and how to account those aspects. So here I am putting forward some of the components which will be useful in quantifying that. So, and second thing is how you will, as a radiation protection specialist who are there sitting around here, their main task is how to integrate the REIA, that is Radiological Environmental Impact Assessment, in the integrated, how will you integrate in the overall safety assessment? That is what we are going to discuss here. So, for any industry, which includes nuclear power also, we should have an overall safety assessment, and which includes economic aspects, social aspects, and environmental aspects. And in the environmental aspects, we have radiological impact assessment and also non-radiological impact assessment. Many times it happens that non-radiological assessment will become more important, more restrictive than the radiological impact, but we should be able to integrate that. So, and RIA should also consider not only human but also non-human species, but also it has to consider present generation as well as the future generation. Finally, you will have a lot of options available with you, and out of that you have to select the best out of that, like, you know. So this involves several iterations. So for example, if at the size selection stage, you will have several sites, and out of which you have to decide economically and environmental impact point of view, which one is the best. And from that, what is the contribution of radiological impact in that. And when you talk about the design stage, what should be the stack height, how much, can it be CCW, or it should be other options are available. So all these hundreds of options will be put forward, considering these economics aspects and all. Out of that, what is the radiological impact for each? That should be estimated by us. So, and context of the radiological impact assessment is very important, because you will have all these nuclear fuel cycle, like mining, milling, then fuel fabrication, nuclear power plant, reprocessing, etc. And also deep repository, decommissioning, norm industry, isotope production, so many are there. And you will have also various stages like site selection, design, construction, operation. So each situation has its own complexities, and there are challenges for each in deciding the source term definition, exposure pathways, time frame for dose assessment, and radionuclide transport models, site parameters, and dosimetric models. I'm going a little fast. So Now, in our safety, all those who are involved in radiological impact assessment, safety series 19 is very common thing which we use. We use the dose of the person at the 30th year of the nuclear power plant. Chitra knows about that. 30th year of the operation, we estimate that. But during the 30th year, what is happening to the biosphere? We have not accounted for that. So this biosphere, the land, air, biota, everything changes when there is a change in the atmosphere, when there is a change in the hydrosphere, there is a change in the geosphere. This fact is not considered. So you should take into account these aspects in this. And also you can see India 100 years before, how does it was like that, now it is like that. So there is a tremendous change happening in this one. So this aspect has to be taken into account based on science, not only on the, because you have geology, you have atmosphere science, you have biological science, this aspect has to be considered. Now, that's why there is a biomass model which takes into account this aspect. In the central, you can see the system understanding, biosphere understanding, which takes input from various sciences, and you will have assessment context, identification, justification of the biosphere, the specification of the biosphere, and based on that you come out with the conceptual model. I'll go through a little faster. I think that we don't have time to, I just wanted to a simple model of the stack release. These are yellow, what you are seeing is the various medias in which, through which the reaches this one, and other columns are giving you the process by which this will give the input for the conceptual model. So based on that you can decide what are the equations to be used, and you can use the kinetic models, or you can use the equilibrium models. So these can be used, and based on this you use assess the dose to the member of the public, and also assess the uncertainty, and if it is fit for the purpose, integrate with the others overall safety. So finally, my conclusion is the Biomass 2020 model is a holistic approach in REIA and decision making, place the REIA issue in relevant context and arrive at the understanding needed to serve the purpose of dose assessment and decision making, provides guidance based on lessons learned, and select appropriate emphasis areas and tools for REIA, and REIA will be integrated with other elements of optimization like radiological, non-radiological, economic, everything. Supports the decision-making process, which is a trade-off, making a choice between various options. So this methodology is being used in present IAEA program, that methods for environmental impact assessment, which I am also participating. And of course, thank you. And afterwards, you should have you have to publish the paper also. So as I'm a member of the International Advisory Board of Journal of Radiological Protection. So if anybody is interested in publishing paper, there are many open access options are there. So if you are interested, please contact me, or you can directly go through the website. So thank you very much.
Thank you, sir, for a very nice presentation and for a suggestion also. We will try to incorporate maybe in future in our calculations the biomass methodology also. Just maybe one question we can take quickly.
Vijay Kumar.
Sir, in the environmental aspects, you have mentioned about radiological impact assessment as well as non-radiological impact assessment.
Yeah.
As a person who has presided over the functioning of all ESLs, of NPCILs, what are the elements of non-radiological impact assessment which should be focused? And how this non-radiological impact assessment should be factored into the ESL programs? Because mostly the ESLs are doing a radiological impact assessment. What are the factors which should be looked at, and elements of non-radiological impact assessment, and how it should be factored into the program, and what retuning or recalibration is required in this connection? Yeah. Just a quick comment from me.
Yeah, it's a very, very, very interesting question. And now Dr. Vinod Kumar is there. He's heading the environmental monitoring and assessment division. I think it's very important. If you consider the history of the operation of a nuclear power plant, the radiological impact is almost very, very less. So what is important is one of the mandates for ESL should be to assess the non-radiological aspect also. One of the things which I can talk about is about the temperature effect, thermal ecological studies, and the other things like so slight changes in the environmental, especially in the context of, that is very important. We had a flood in Kaiga, unexpected flood in Kaiga, and now that is because of the, and there are many new unexpected climate changes are happening, like there is a vast change in the groundwater. Earlier we were getting at the 30 meter, now it is in 100 meter. Now what is the impact of this groundwater depletion to the environment? Like crops are changing,
Sir,
people's habits are changing, all those things are changing.
Sir, sorry to interrupt you, sir. We can I think take the discussion to the lunch time. So
okay.
We have just one more last.
Okay, no problem. Okay, no problem. Thank you very much for the.
Thank you, sir.
So now there is a special lecture from Heavy Water Board. So we don't have the name of the presenter. So you have 10 minutes, 8 plus 2. So kindly try to finish it in 8 minutes. Thank you. So first of all, I would like to introduce myself. My name is Nilesh Veer. I am from Heavy Water Board, and I would like to thank the organizers for giving me an opportunity to talk here about the activities and accomplishments of Heavy Water Board. So the journey of Heavy Water Board started with Bhabha's vision, and these are the quotes of Bhabha back in 1948, that government should explore immediately the possibility of utilizing cheap hydroelectric power in India for manufacturing of heavy water on one hand, and for our own requirement, and on the other hand for export to other countries. So with this, Heavy Water Board was given a mandate by the Department of Atomic Energy. Heavy Water Board is involved in the production of heavy water, basically for the nuclear applications, and also the specialty materials, including like enriched boron, nuclear solvents, and potassium for the nuclear applications. And for non-nuclear applications, which are recently becoming very popular, these are the non-nuclear applications of Heavy Water Board, and heavy water like deuterated NMR solvents, and then production of deuterium gas, production of O18 water, and deuterium depleted water, which is actually deuterium depleted water is a reject of our plant. So this is a pan-India presence of Heavy Water Board. We have plant in north, Heavy Water Plant Kota. Then we have Heavy Water Board Facility Baroda, which was earlier Heavy Water Plant, now converted to Heavy Water Board Facility Baroda. And then Heavy Water Plant Hazira, then Heavy Water Board Facility Mumbai, which is basically a technology development hub sort of a unit. And then we have Heavy Water Plant Thal in the west. Then down south we have Heavy Water Plant Tuticorin, and in Odisha we have Heavy Water Plant Talcher, which is now converted to Heavy Water Board Facilities Talcher. So in Heavy Water Board's contribution for the 3-stage nuclear power program, you can see here in the first stage we are contributing for supply of heavy water as a coolant and as a moderator, and then supply of specialty solvents in nuclear fuel recycling. This is basically at the front end also, and in the second cycle also. So this is for fuel reprocessing. So solvents like TBP
DEFA, topo tie-up. And then in the stage 2, we are supplying boron carbide pellets for fast breeder reactor, and also a supply of sodium as a coolant for fast breeder reactor. In stage 3, of course, heavy water supply. These are the different facilities of and plants of heavy water board. This is heavy water plant Baroda. It was established in 1977 and subsequently got decommissioned and now presently converted into heavy water board facility Baroda, where solvent production and sodium production is in progress. So here basically we produce TBP, tributyl phosphate, and nuclear grade sodium. So I'd like to add here is we have already supplied around 600 tons of nuclear grade sodium for FBTR program. Followed by heavy water plant Tuticorin. This is the second generation plant. This is based on again the ammonia hydrogen exchange process, and it was set up in 1987 and was operational up to 2007. Unfortunately, we had to take shutdown of this plant in 2007. But then further, due to stoppage of SPIC basically, now as SPIC has also restarted, we have also restarted the heavy water plant Tuticorin, and right now it is in the restart up stage. Basically the loop testing and commissioning is in progress. We also have a solvent synthesis plant, that is solvent production plant in heavy water plant Tuticorin, where we produce TBP, tie-up, DOA, topo, and DEFA2, is PC88. Heavy water plant Kota, this was the first generation plant based on H2S water biothermal exchange process, and it was established in 1985 and still it is in operation and doing wonderfully, producing heavy water beyond design capacity. Steam and power for this plant comes from the RAPS. These are the photographs, erection photographs of heavy water plant Kota. Here we have taken up a new developmental activity, that is production of deuterium depleted water. Now this deuterium depleted water seems to have a demand for medical purposes, that we'll see in the proceeding slide. So this is the inauguration of the DDW facility at Kota recently. And next is a heavy water plant Talcher. This is again based on the biothermal ammonia hydrogen isotopic exchange process. Presently the plant is dismantled, and here we have taken up facilities like synthesis of solvent. This is basically the starting point of solvent synthesis in heavy water board. This was the first plant, and based on this plant we have developed the industrial scale plant. So this was basically the pilot plant for solvent synthesis, and also we are carrying out this KBA4 production and integrated KBA4 production for supplying to boron pelletization. So this is inauguration of B11 enrichment facility of Talcher. Heavy water plant Thal. This is again based on ammonia hydrogen monothermal exchange process with a design capacity of 85 metric tons per annum. It was commissioned in 1987. This is second generation plant of ammonia hydrogen monothermal process. Followed by Hazira. This is the youngest plant on ammonia hydrogen monothermal process with a capacity of 110 metric ton per annum of nuclear grade heavy water. This was commissioned in 1990. Further, heavy water board also has been contributing for establishing the technologies developed by BRC. And this is one of the technology which is developed by IGCAR jointly with IGCAR and BRC. The HG SBR granules were developed by BRC. These are for the treatment of sewage. So in collaboration with Surat Municipal Corporation, as we have presence of heavy water in the form of heavy water plant Hazira, we have set up a plant, and it has been handed over to the Surat Municipal Corporation recently. The heavy water plant Manuguru, this is a flagship plant of heavy water board, and this is the biggest heavy water producing plant in our country, and it is under operation since last 35 years, and we also have a captive power plant. So here we not only produce the steam requirement and power requirement for our heavy water production, but also we export power to the grid. In addition to the coal-based plants, so these are the coal transport ropeways, where it is linked with the Singareni coal mines. From all the way from Singareni coal mines, the coal comes to heavy water CPP plant. And in addition to that, we also have commissioned in 2015 a solar power plant for 12 megawatt electric. Further to heavy water production, Heavy Water Board has also produced O18 water. O18 water is used basically for production of F18. This is fluorodeoxy glucose. This is used as a tracer for cancer detection. This is having a huge demand. Basically, all the O18 required in our country used to be imported, but now with the production of this O18 from Heavy Water Board, the import substitute is provided. Further in Heavy Water Plant Manuguru, we have the B10, that is boron carbide pelletization plant, where the KBF4 produced in Talcher comes here, which is then further converted to boron carbide. This is Heavy Water Board facilities Mumbai. This is located in the premises of RCF Chembur, and here several activities are taken up presently for the development of the technologies, that is upscaling of the technologies developed by BRC. Some of them are recovery of cobalt, nickel and moly from the MDN alloy scrap. This is a margin steel alloy scrap of Midani. Then recovery of metal G from bare liquor, hydrogen production by IS process, and recovery of helium from purged gas. So these are the diversification products of heavy water. Deuterated NMR solvents, then deuterium depleted water. Presently, deuterium depleted water has shown some good results.
Yeah, time is up, so kindly finish.
Yeah, good results. So we have collaborated with Actrac for further. I mean, it is said to it is some preliminary study says that it reduces the cell, growth of cancer cells by reducing the metabolism. So then nuclear solvents, again these are used in the front end as well as back end of fuel cycle, and O18 for the PET scanning. So deuterated optic fibers also have an application. Basically by deuterating these electronic components, we increase their life. So as we have seen in the first slide, the vision of Bhabha is for producing heavy water for India as well as for export. So recently we have exported heavy water, in particularly in last year, around hundreds of metric ton of heavy water has been exported, and crores of revenue has been generated in US dollars. And we have also signed an agreement with Argentina for supply of heavy water for the PHWR program for a period of 4 years. So these are the locations like countries like USA, France and Korea, where we have supplied heavy water. This is the wheeling of technology, that is indigenization of heavy water production. Not only heavy water but also O18 supply we are supplying through BRIT, and then production of solvents, boron carbide pellets, deuterium depleted water, and supply of this B11 enriched B11 for electronic purpose to ECIL, right? So this is Make in India concept, wherein all the products what we have. Thank you.
So now the presentation is open for a couple of questions, if there are. Otherwise, you can ask questions during lunchtime also. So let us thank the speaker once again. So now,
thank you. Thank you.
Now we have completed all the talks after the tea session. So I would like to once again thank Dr. R.B. Oza, Head RSSD, and other speakers for this session. So thank you, one and all.
Thank you to all of you. So the session is closed now, S9.
Thank you so much, all the speakers. I request Dr. A. Vinod Kumar, Head EMAD BARC, to present a memento to Chair Dr. Jnana Prakash and Co-Chair Dr. S. Chitra as a token of gratitude. Thank you, sir. It's now time for lunch. Please note, after lunch, Best Paper Award ceremony will be held, which is chaired by Professor P.L. Dhamma, Honorable Vice Chancellor, Mangalore University, at sharp 2:15 p.m. I repeat, after lunch, Best Paper Award ceremony will be held, which is chaired by Professor P.L. Dharma, Honorable Vice Chancellor, Mangalore University, at sharp 2:15 p.m. Please have lunch and come back on time.
Hello. I just want to make one announcement. Inside your bag, there was one leaflet for the young generation.
Good afternoon, everyone, and welcome back. Before we start this session, I have a small announcement. We have not received the PPT of SN Namita T1003. So if Ms. Namita is present over here, please hand over your PPT to us as soon as possible. To begin the session will be chaired by Dr. A. Vinod Kumar, Head EMAD BARC, and co-chaired by Dr. Vandana Pulani, Head ERMS EMAD BARC. Let's have a small introduction about chair and co-chair.
The chair of the session, Dr. A. Vinod Kumar, is an environmental engineer, is a head EMAD BARC with more than 30 years of experience in the field of environmental monitoring and atmospheric modeling. He has more than 450 research publications in journals, conferences, books, etc., covering wide range of environmental aspects. Currently, he is head Environmental Monitoring and Assessment Division, BRC, Mumbai, and is responsible for the environmental and radiological surveillance around each of the nuclear power plant sites, BRC facilities at Trombay and Visakhapatnam, and in development and deployment of environmental gamma radiation monitors all over the country under the Indian Environmental Radiation Monitoring Network. The co-chair of the session, Dr. Vandana Pulani, Scientific Officer, Head, Environmental Radioactivity Measurement Section of Environmental Monitoring and Assessment Division, BARC, has experience of more than 30 years in the field of environmental radiological surveillance around the nuclear facilities. She and her group ensures regulatory compliance by the facilities and assess the impact of nuclear facilities on the environment. She has expertise in the development of analytical methodologies at ultra trace levels in the environment, studies on migration of radionuclides in solid, groundwater, plants, and other matrices. She is the national coordinator of IAEA RCA projects and CRPS. She has published her research work in a number of high-impact peer-reviewed journals. Now, I invite the chair of the session, Dr. A. Vinod Kumar sir, and co-chair Dr. Vandana Pulani ma'am, onto the dais. And we are handing over the session to you, ma'am.
Thank you, organizers, for the brief introduction. So without delaying much, so we are anyway running short of time. I will call Mr. C.B. Dusane for his presentation on the topic application of in-house synthesized hydroxyapatite for uranium recovery from acid raffinate. Your time is 10 minutes.
Thank you, sir. Thank you, madam. I am thankful to organizers of ICRP NC 2025 for giving me an opportunity for the presentation of my work. My work is application of in-house synthesized hydroxyapatite for uranium recovery from acidic raffinate samples. As we all know, uranium is a very valuable material in the nuclear industry. It is used in the reactor for the nuclear electricity production, which is considered as one of the most green energy production. Uranium can be extracted from the primary sources like uranium ore by mining, milling, acid leaching, solvent extraction. Uranium can be also recovered from secondary sources like phosphate rock leachate, seawater, and nuclear industry process effluent, which is becoming more important due to the environmental impact, safety aspect. As we know, front-end nuclear cycle uranium last stage of separation from LOK is solvent extraction. And there are some inherent limitation of the solvent extraction method. Therefore, trace amount of unrecoverable uranium is released as a acidic raffinate solution. And this trace amount of uranium, if not extracted, it will be the loss of resources. Therefore, efficient recovery of this uranium from industrial effluents is critical for environmental sustainability and effective resource utilization. There are many synthetic materials are studied for the extraction of uranium from various secondary sources, including process effluents. However, very few studies were explored on the application of natural or the modified natural adsorbent. So, main advantage of natural adsorbent are they are abundant and cost effective and also environmental friendly. Hence, my study is focused on the application of modified natural adsorbent for the removal and recovery of uranium from the process streams, basically nuclear industry process stream. So, we have, this is flowchart of synthesis of HA from the eggshell. We have collected these kitchen waste, raw eggshells from the canteen and washed, and then we have make it powder, and this powder is calcinated at 1000 degrees Celsius to remove the organic interference. Then we have dissolved this powder into nitric acid, and this solution was allowed to react under certain specific conditions with phosphoric acid like pH 10.5 and calcium to phosphorus ratio 1 to 1.67, and this precipitate was allowed to age. And then after aging the precipitate, we have washed this multiple time and dried and preserved for our further experiment. Now, it is very important that we have synthesized from this eggshell powder, so we have to confirm the characterization of the synthesized material. For that, we have done the XRD analysis, and the results are here. Sharp peaks of the spectrum indicate that material is crystalline in the nature, and these red peaks are from standard HA material, and the blue line peaks are from our synthesized material. And many authors reported the same peak, so which confirm the formation of HA is completed. Then further we have done FTIR spectrum of the material to see the presence of functional groups. So peak at 1026 and 1087 confirm the presence of phosphate functional group, and one small peak at 630 you can see it confirms the presence of hydroxyl group. And similar peaks were reported by various authors like Sadat Samina, Nagun et al., which confirms the formation of HA. Before application on the acidic raffinate sample, we have done some preliminary studies. For that, we have done laboratory batch experiment, and it is very important to know the sorption kinetic and optimum pH condition for the efficient extraction of uranium. So, we have taken very small amount of HA and reacted with a 25 ml uranium spiked deionized water for various time interval, and supernatant was analyzed for the uranium after that predetermined time interval. We have also conducted the pH variation study from pH range 4 to 9, and using this optimized pH condition, column experiment was conducted on actual acidic effluent sample. Result shows here, first graph, that variation of uranium uptake with varying contact time. We can see result showed that more than 95% of the spike uranium concentration was getting adsorbed on the HA within 5 minutes. So, which indicates the very rapid sorption kinetics, as well as the from table of pH variation study. pH optimum pH condition of sorption is taken as 4 to 6. Further, we have done the sorption mechanism study by XPS analysis. So, in first figure you can see the presence of that is from HA. So, phosphorus, calcium, carbon and oxygen in the material can be seen. In second peak, one extra double peak is seen, that is confirmation of uranium is adsorbed on the HA material. As well as in fourth figure we can see the area ratio, that colored phosphate, hydroxide and oxygen bonded to calcium peak were changed after the adsorption of uranium. So, this suggests that participation of this functional group in the adsorption of uranium. Sorry. In next figure, we can see there is a no peak shift in case of calcium. So we can say that calcium does not play any role in the uranium adsorption. Now, in last figure, you can see there is a peak shift small, which confirm the uranium get adsorbed and having the strong interaction between phosphate group and uranium ion. So from the above study, we can confirm that or conclude that surface complexation and ion exchange are the two major mechanisms for the adsorption of uranium. Now, the application of this HA material on real acidic raffinate sample under optimized conditions. So, concentration of uranium in the acidic raffinate solution was analyzed by HPG, and to evaluate the removal efficiency of the synthesized material, 1 gram of HA was packed in the plastic column and the acidic raffinate solution was passed through the column. Now, after sorption, after the passing through column, we have again analyzed for uranium using HPG detector, and we found it is below detection limit, that is 46 millibecquerel per ml. So, continuous flow through experiment result shows that uranium removal efficiency is more than 92%, which indicates the high affinity of this material for the uranium even in presence of major ions. Sorry, this back extraction of uranium again is very important step, where we have used the two types of solution for this. One is dilute nitric acid and another is sodium carbonate. So in case of nitric acid media, we found there is some dissolution of material. So for further experiment, we have used the sodium carbonate, and by using the different concentration of sodium carbonate, it is found that 0.1 molar solution is sufficient for the uranium back extraction. And with this optimized solution, our back extraction efficiency was 94 plus minus 2%. Conclusions. In-house synthesized hydroxyapatite we have made from the kitchen waste, which shows an excellent selectivity for uranium removal from this acidic raffinate sample, which helps us in the environmental safety for the sustainable growth. And this developed eco-friendly, cost-effective method, which is addressing the trace uranium losses in the industry effluent, and which also aids in the waste minimization. We all are looking towards this wealth from the waste. And with high selectivity and good absorption capacity, this developed methodology can be scaled up. Further work is in progress. Finally, I would like to acknowledge Dr. Vinod Kumar, Head EMAD, Dr. A.K. Singh, Head UAD for constant support and encouragement. And I am also thankful to following experts for providing their necessary instrument support from various divisions of BRC, Dr. Pradeep Samoi, PDD for XRD analysis, Dr. Deepak Tyagi for XPS, Dr. Sabyasachi Raut for FTIR, and Dr. D.K. Chaudhary and Lalita Nair from the trace analysis group. Thank you.
Thank you, Chetan, for keeping within the time. A good presentation on using biomaterial and the capability of re-extraction of uranium from the adsorbed material. The paper is open for 1 or 2 questions, please. Yeah, Sarth, yeah.
So why you have used nitric acid on one side and sodium carbonate? Any reason for extraction, re-extraction of uranium?
Because it can be get extracted in nitric acid, uranium nitrate, and sodium, as we know, carbonate having affinity for uranium.
So for nitric acid, how much efficiency you got?
Not efficiency, we have not used, sir, because some dissolution has happened. So further we have used only sodium carbonate only.
Okay. Okay.
Thank you.
So, if there are no more questions, we thank the speaker. So, we are happy to inform that our Honorable Vice Chancellor has arrived. I think we'll give the speak to Dr. Karunakara to proceed with the next program. Short break on this presentation.
I request the event managers to clear the stage for the award ceremony. Excellence is not a destination. It is a continuous journey that never ends. Good afternoon, ladies and gentlemen. As we pause in the midst of this intellectually enriching conference, we take this special moment to honor excellence in research and innovation. I request Dr. Karunakaran, convener IARP, to escort the dignitaries onto the dais. We are privileged to have Professor P.L. Dharma, Honorable Vice Chancellor, Mangalore University, Sri Raju Mogavira, Registrar, Mangalore University, Dr. A. Vinod Kumar, Head EMAD, BARC, Dr. Karunakaran, Convener, IARP 2025, Dr. S. Anand, Secretary, IARP, Best Poster Award is not just about recognizing outstanding work, but also about celebrating the spirit of inquiry, dedication, and perseverance that drives scientific progress. The research presented at this conference has contributed significantly to our collective understanding of radiation protection and nuclear safety, and today we honor the brightest minds behind these contributions. To formally begin this ceremony, I now invite Dr. Karunakaran, Convener, IARP 2025, to extend a warm welcome to our distinguished guests and esteemed audience.
A very good afternoon to all the dignitaries on the dais and off the dais. I am really happy to stand before you to have this a small function on the award distribution of the Best Poster Awards. And for this function, we have with us our Honorable Vice Chancellor, Professor P.L. Dharma, who is the backbone for the success of this conference. And when IARP team, Dr. Anand and Dr. Vinod Kumar, they approached Mangalore University, or we approached, because this conference, there were other competitors also to host, and I approached them, and they wrote the letter, and I went to the Vice Chancellor with a letter. Sir, we have a opportunity to host this. There was no second thought with our Vice Chancellor. He said, just go ahead, that's all. And that gave us the energy to accept this offer of hosting this conference here. And subsequently, the support he has been extending. And because of that, we were, we are able to achieve a sort of a, this excellence in organizing this conference. So, unfortunately, he was supposed to be with us on the inauguration day. He was supposed to preside the function on that inauguration day. Unfortunately, on that one day before, he got a call from the governor office, and immediately he has to leave. And when he said, immediately called me, Karunakar, this is the situation. I have to go, but with the great unhappiness, I am going there. But don't be afraid of the thing. You carry on. The whole team is with you, and I will join you soon. So that gives the courage, and gave the courage even during his absence. And today morning, we had planned to have this today morning. So unfortunately, one of our colleagues, she passed away, and suddenly he had to leave there. So even though he went there, and suddenly he rushed back to here, and he is with us now. And on behalf of all of you, and on behalf of the delegates, and on behalf of Mangalore University, on behalf of this IARP team, and on behalf of my personal team and on behalf of one and all, I welcome our Professor P.L. Dharma, who is the alumni of our university. He was a professor, he was a student here, and then he was a faculty, and then of political science, one of the senior most faculty in this campus, and then he was the registrar evaluation of this university, and in 2024 he was appointed as the Vice Chancellor. So he is the one who is the guiding us in all the aspects. Sir, we thank you on behalf of the organizing team for being with us. And we also have with us Dr. Vinod Kumar, our collaborator for many, many years, whom you know. I welcome him also. I welcome Dr. S. Anand, who is the Secretary of the IARP, again our collaborator for several, almost 2 decades now. So I welcome him also for this afternoon function. I have our registrar, with whom you have been interacting for the last 3 days. So he is also one of the key persons for the success of this conference. So I also welcome him for this function. So may I request one of our Avani to hand over a bouquet to our Honorable Vice Chancellor and welcome him florally. Thank you very much.
Thank you, sir. Now, the much awaited moment has arrived, the announcement of the Best Poster Awards. These awards recognize outstanding research that has stood out of its originality, scientific rigor, and contribution to the field of radiation protection and nuclear safety. The selection process has been rigorous, and today we acknowledge the researchers whose work exemplifies excellence. I now invite Dr. Vandana Pulani, Head ERMS EMAD BARC, to read out the names of award winners.
Thank you, Avni. Very good afternoon, dignitaries on the dais, off the dais, and dear delegates. So Avni has already talked about the spirit with which we have to take the awards. Yes, I'm going to announce the poster awards. We have taken efforts to have cover each and every poster, so you would be glad to know that there were about 220 posters, of which almost 210 were displayed. Some people may not have come, but we have tried to have a number of referees visiting each of the posters, meeting the authors, and deciding about. But I would definitely like to say that we are very much indebted that you all have contributed towards the technical program of this conference with wholeheartedly and have taken the efforts. We are very much grateful for that. But yes, there has to be some selection criteria. So based on that, we declare the poster awards. So I would like to share that there are 4 poster awards, 3 instituted by IARP and 1 by Mangalore University. So based on the reviews of the referees, I would like to announce the first poster award goes to the poster on charged aerosol dynamics behavior for improving the fast reactor safety assessment during severe accident modeling aspect by Ms. Usha Pujala, Shri Sarangpani, and S. Chandrasekharan from IGCAR Kalpakam. I would request, I will request the Vice Chancellor of Mangalore University to please present the certificate. The award carries a certificate and a cash prize. So can we have members, one of the group from Usha Pujala, Sarangpani, Ramar or Chandrasekharan? Or anybody from IGCAR, kindly please collect the certificate on their behalf. Yes, we have Dr. Kothai coming to receive the award from representing IGCAR. Thank you, Kothai. So the next award, the second award for poster presentation, is awarded to the topic on novel tri-layered polymer composite, a radiative protective medical wear, which was presented by Ms. Sherry Shazan, Ambika M, Nagaya N, Sri Lakshmi, Deepika DN. They are from the Department of Physics, MS Ramaiah Institute of Technology, Bangalore. So there was a tie for the second prize. So there is another award for the second position of the posters. So this award goes to soil to rice transfer factor FV values for stable elements for the tropical monsoon climate region of the west coast of India, to Mr. Avanish, Dr. N. Karunakara, Dr. P.M. Ravi, N.S. Magesh and T.R. Reshmi from Kerar, Mangalore University. Okay, so Dr. Karunakara is receiving on behalf of his team. Thank you, sir. So the third award in this poster session category goes to the topic on theoretical estimation of efficiency for argon 41 measurements in sodium iodide thallium detector using Gen 4 code to Mr. Lalit Vajpayee, Saurabh Sood and Shri Ras Bihari Rakesh from the Health Physics Division, BARC, Mumbai. Can we have somebody from Health Physics Division to please receive the award? So we have P.S. Lenka from Health Physics Division taking the award on behalf of Lalit Vajpayee. So then again, there is a tie, and this tie is not two-way, it is three-way. So we have the second prize in the third prize category on design and development of neutron flux monitors by Srimati Vaishali M. Thakur, Shri Amit Jain, Shri Praveen Sawant and Prabol Chaudhary. And so the third prize, not third, it is equally, but third person in the third prize category is topic on parametric evaluation of matrix influences on detector response across broad range of photon energies by Miss M. Margaret, Shri S. Chandrasekharan, Shri C.V. Srinivas, Vidya Sundara Rajan from IGCAR Kalpakkam. So, Dr. Kothai, I think I can request you again to please collect the award on their behalf. Thank you, sir. So these are all in the poster awards. We'll be announcing the oral awards at the end of the session. Thank you very much.
Thank you, ma'am. And congratulations to all the award winners. Now, I request Dr. A. Vinod Kumar, Head EMAD BARC, to share his opinion about the conference. Sir, please.
Thanks to Vice Chancellor that who could spare some time and attend our conference. And as indicated by Professor Karunakara, we had a wholehearted support from the VC the moment when we met him. So all thanks to him. And I thank all the Mangalore University staff, our registrar and other team members along with Dr. Karunakara who made this program successful. Thank you once again to all the members. Thank you.
Thank you, sir. Now, I request our Honorable Registrar, Sri Raju Mogavira, to speak a few words about the conference.
Good afternoon, everybody. Honorable Vice Chancellor and dignitaries on the dais and my dear delegates. It has been a hectic 3 days for Mangalore University for conducting this wonderful conference, and without an iota of doubt, I can say that it's a hugely successful national conference. Thank you all the delegates for making it happen. Let me congratulate the winners once again. But whether somebody wins or not, it's indeed a great moment of pride that all of you have come from every nook and corner of this country and gathered here and hugely benefited from the proceedings of the last 3 days. I would like to share a couple of data. Of course, it's not about science or nuclear science, it's something else. All of you are working in the science field, and I'm not a science man, neither my Vice Chancellor. Only we two are the odd men out here. India is a $4 trillion economy right now, and India is the 5th largest economy in the world. The dream of our Prime Minister is to see that India becomes a $7 trillion economy by 2030. That's hardly 5 years later. As we are all aware of, any country to economically progress, we need a good, infrastructurally strong economy. And energy is the one source which can propel our progress into that realm, the next stage. It is said that India is the 3rd largest consumer when it comes to power. I'm not just quoting anybody here, I'm referring to the website of the Power Ministry of Government of India. Right now, our capacity is something around 4,60,000 megawatts in this country. And as we progress economically, we need a huge amount of power. Right now, nearly 53% of Indian power production is coming from fossil fuels. It is coal, it is lignite, it's diesel, and all those gases. And the 10% comes from hydroelectric, 35% come from wind, solar, and other renewable energy sources, and just 2% from nuclear sources. The same was discussed by
Dr. Shuklaji the other day in the inauguration day, the contribution from nuclear reactors is just 2%. If we need to generate a large amount of power without compromising on the environmental aspects, then nuclear energy is the way to go. I think if we take that into a perspective, what you have been doing in all these 3 days will make sense. Although you may be working in your labs on a specific project or a specific item, but if you take the whole picture, or if you have the holistic view, then definitely we are all working for a single cause of sustainable development of this country and sustainable development goals that are set by the international agencies for all countries. I think we are on our way, but there's a huge scope for us to improve and generate more power. And when we say generate more power, definitely the question of environmental effects, the carbon emissions, all these issues will come into picture, and we look forward to you. We see some of the finest scientific brains of this country here in this hall, and it's your responsibility, and it's an honor to see that you come out with new solutions wherein we can have both energy as well as less carbon emissions, and you can take forward this country, and we have faith in you. Secondly, I would like to thank Indian Association of Radiation Protection for having chosen Mangalore University for hosting its 35th National Conference. It's indeed a moment of honor for Mangalore University to host a conference of this scale in a short span of, say, one and a half month. But I think we lived up to our expectation, and we lived up to your expectations, and we have done it very systematically. And we are truly indebted to IARP for choosing Mangalore University. Thank you, the office bearers of Ramesh and Prabhuji, for having come here and made it a success. I also thank the officers and members of the organizing committee, all the young boys and girls here who have been working for the last 3 to 4 weeks for making this a success. We have covered a beautiful coverage in press, both in English and Kannada, and we are thankful that our press people got an opportunity to interact with stalwarts like Shuklaji and Aswal and other great minds. And finally, I would like to thank all the delegates who took time and effort to reach Mangalore. Of course, it's another 20 kilometers from the university, lies 20 kilometers from Mangalore city, but still you made it, and I really thank, and I would like to place my appreciation on record for all of you. Thank you.
Thank you so much, sir. It is now my privilege to invite the chairperson of this ceremony, Professor P.L. Dharma, Honorable Vice Chancellor, Mangalore University, to share his thoughts with us.
Namaskar to all dear friends from the science family, dear scientists, all the dignitaries on the dais. I have all the time fear about science. And in fact, I'm not a student of science, as our registrar said. Science has always created fear in me. And even today, when my friend was reading the titles of those posters, which I was not able to even understand what it is, I still believe that the science continues to haunt us and then trouble us in a big way. I remember the days where I, also as an employee of the government, very strongly, very actively working against the entire nuclear, project throughout the world. When the major treaties were signed, SALT I, Strategic Arms Limitations Talk, SALT I and SALT II, and then some of those major treaties called Comprehensive Test Ban Treaties, the major theme that was given to us to discuss and then speak about was the nuclear weapons. I still remember how my teachers and the guests, like all the scientists here who came here, and then wherever I went and attended the seminars and the conferences, they were trying to tell us how problematic it is as far as the nuclear bombs are concerned. Back in Mangalore University, with the help of IARP, our good friend, colleague, Professor Karunakar has come out with a wonderful project, and he has been doing it for the last almost a couple of years. And he said, here is a study, here is a center which is studying on the nuclear energy, which is going to be people friendly. I was wondering whether it is true or not. Now I have the data. Now I have all those proofs provided by the scientists, young scholars, where we understand that the research has reached to that level, to that extent, where at one point of time, I was worried about something is becoming absolutely human friendly these days. I'm extremely happy, and I congratulate all those scientists who have brought us away from fear and make us understand, even though we are not science students, telling us that the nuclear energy can also be used for the progress, development, and the kind of activities our registrar said. I congratulate the team which is working day and night to see that the human beings are protected, the environment is protected, every species on the earth is being protected today in India, not only in India, throughout the world. Let your journey, mission continue to see that you not only save the human beings, also you save the world. At the same time, my dear friends, I missed the grand ceremony, opening ceremony, though I was just watching the video back in Bangalore, and I saw how absolutely apt it was when the inauguration ceremony took place and the major themes were presented. Later, I also saw press were interacting with guests and some of those interesting things that were carried out by the national, daily, which our registrars was stressing on. I'm so happy, and I'm really so happy that India is back in terms of winning the confidence of everybody from every nook and corner, where nuclear energy today is bringing people together, connecting people together. And this mission must continue. Mangalore University will be always with you in terms of the kind of research that you conduct, in terms of the academic activities that you carry on, where you don't miss human beings and you don't miss all the species on the earth. I thank everybody who made it to Mangalore University, and I believe you enjoyed our atmosphere here. We are also one of the green campus, as declared by the agencies, different agencies, and I'm sure how we love environment. It's not just that you love environment and therefore you have the saplings and the trees and therefore everywhere it looks green. Unless all of us join together, including the scientists of top rank dealing with all these IARP issues, environment cannot be protected. If a small area where you plant, saplings and then grow trees and then say, look, this is what the area that we do. And somewhere at the end of the world or at different part of the world, you have a huge fire destroying the forest, killing all species. And then you have huge sky-reaching buildings coming up where the temperature is reaching to the sky. and you have all these crisscross activities going on throughout the world. Unless all of us think in the same way, where we think that environment is equal to God and goddesses, nothing will protect us in the next few decades to come. People might have taken care to see if somewhere and here and there, hodgepodge environmental protection measures have been introduced. Yet, damage is going on. In Mangalore, we are not able to catch fish, which otherwise what was expected. Almost 30 to 35% of the people are living depending upon the sea. But the sea is ditching us. It is not taking care of us. The people who have depended on the sea are not, living properly as much as you do. There are people today who have started growing aracanut and then coconut today, where you don't have even yielding of coconut and aracanut today. So we are all worried. We are all worried. The agriculture that we believe today and we trusted on, and then we thought that that was going to be almost our God and goddesses, is going away from us. We do not have proper drinking water today. All the diseases, if you go to a dermatologist, he or she would say, look, you need to be very careful about the water that you drink. All the doctors, particularly dealing with ophthalmology, they would also say, look, your problem, your vision today, reduced vision is linked to the food that you consume and then the weather in which you live. One or the other way, every doctor ends up saying that you have one or the other problem with this environment. So my dear, all scientists, young scientists, I have a very humble request with all of you to see that you may have the piecemeal engineering to cure diseases whenever I consult you. All those diseases that we have today may have a temporary relief, but I'm very, very particularly asking you that can we do away with all these things so that this world is given to our next generation, absolutely youngsters, bubbling with all, energy, planning to enjoy their future tomorrow, and then please give this environment to them. Let them live happily. Let this world also give them the opportunity to live and then have the next generation happily. This is what the request I can make, my dear friends. I'm sure every time when you conduct, this is 35th, when you go to 36th and 37th, and I'm sure you go to the 100th seminar conference also. In every conference, unless this is taken care, I think all these small chota-mota areas where you protect never protects the entire world. Today, as our registrars have said, our requirements of energy is not just increasing day by day. It is also becoming very divisive, different expectations are there. Unless you respond specifically on specific issues, things would be very, very difficult. I'm really sorry to tell you, my dear friends, our hospitals here, we have 6 medical colleges, which I don't think that you find elsewhere. Our hospitals are just filled with large number of patients with not common diseases. They wouldn't come and say, look, stomach pain, headache, and then fever. Sometimes it's difficult to even diagnose what kind of diseases that she or he is being affected with. Doctors are finding it very difficult to answer. Chalo, wait karo for some time and see what happens. Take these medicines. If it responds, maybe this is what exactly the disease is also, and then come back and then see what happens. This is how the medical field is now being, challenged with the kind of diseases that we have. 6 medical colleges, 24/7, you serve them. Yet the doctors are absolutely busy and they are absolutely not, spending time elsewhere. I'm just trying to give you a small hint. Unlike our registrar gave you data, I'm giving you this abstract picture of what is happening. I'm grateful to all my young friends from the Department of Physics, Medical Physics, particularly Professor Karunakar, for taking this risk all the time. He is the one who always takes risk. I really appreciate being absolutely young boy. You take risk, and you're sure, and you also tell everybody, unless you take risk in life, nothing is going to be achieved. And you did it, and you have shown, my dear friend, and also colleague Professor Karunakar, you with your students and the colleagues of the campus, you have made it, a grand success. Thank you so much, my dear young friends who all the way come from different parts of India. and this is a small campus. I believe you might have enjoyed the hospitality, and my young friends, the students from the Department of Medical Physics are always on the toe. That is what I was given all the time in the evening. He was trying to, brief me as to what has happened at the whole day. Yesterday, Anait also spoke and then told me, look, this is what is the update. And I'm sure our volunteers and all the research scholars have helped you whenever you wanted their help. Please come back to Mangalore University. Mangalore University always honor you, particularly when you take up the research which helps human beings. Thank you so much. Please come back once again. We will be very happy to receive you, and particularly Professor Karunakar will always be with you in terms of your ventures, any kind of ventures, joint ventures, and whenever you need help, please ping him and please trouble him. He is always there for you, and I'm extremely happy I could be part of this conference of 35th IARP and great officers. Thank you so much for thinking of Mangalore University and helping us in hosting this conference. My young friends, thanks to all of you for a wonderful work that you did. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಮತ್ತೊಮ್ಮೆ ತಾವು ಮಂಗಳೂರಿಗೆ ಬನ್ನಿ. ಮಂಗಳೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯ ನಿಮ್ಮನ್ನೆಲ್ಲರನ್ನು ಸ್ವಾಗತಿಸುತ್ತದೆ. ನಮಸ್ಕಾರ.
Thank you so much, sir, for your kind words. I request Dr. S. Anand, Secretary IARP, to present a memento to Professor P.L. Dharma, Honorable Vice Chancellor, Mangalore University, as a token of love and respect. Thank you, sir. I now invite Dr. Karunakara N. for the vote of thanks.
Good afternoon again. On behalf of the organizing committee, National Advisory Committee, and the local organizing committee of this conference, I would like to thank our beloved Vice Chancellor, Professor P.L. Dharma, for being with us this afternoon. And he is the patron of this conference. And as I said, his contribution to this work, the success of this conference, and the leadership has made a difference. On behalf of all the delegates and the organizers, I would like to thank you. I would also like to thank our beloved Registrar, Sri Raju Magavira, for supporting us in every aspect. And also I would like to thank the IARP team, Dr. Vinod Kumar and Dr. Anand, Dr. Aswal, and many other scientists who had to leave this afternoon after lunch to catch a flight at 3:30. And I thank the whole team. And also I would like to thank the funding agencies, BRNS, ANRF, CSIR, and we have received positive reply from INSA, and also the sponsorships we could get for organizing these sponsors who supported supported this conference. So I thank you one and all, and let us give a big round of applause for the whole team sitting in the dais.
With that, we come to the end of this grand event. On behalf of Mangalore University and the Indian Association for Radiation Protection, we extend our sincere gratitude to all the dignitaries, award winners, and participants for making this conference a grand success. We now transition back into our conference sessions, and I request the event managers to clear the stage for oral presentations.
I think welcome back to the technical session. Let's call on next speaker, Mr. Kali Prasad, and for his oral presentation.
Is it okay? Time up. Yeah, good afternoon all. I am thankful to IARP for giving opportunity to present here. My topic is seasonal variation of uranium concentration in water produced around Chikkballapura district, Karnataka. So this is uranium. Already we discussed a lot from last 3 days. Okay, how uranium is useful. Okay, and how there is some advantages as well as some disadvantages will come in all the way. Okay, here also just I am mentioning about how the we know that when there are different isotopes are there in uranium. Uranium 238, 235, and 234. Okay, most abundant is that uranium 238. And 234 is the second one, but the percentage is only 0.79%. The remaining one is 0.005%. Okay, but my concern is that okay, whatever the uranium is there, uranium we are using only for most of the time for the good purpose in terms of energy production, as well as it causes many health issues. Okay, in especially I am taking in terms of uranium in water. Why? The reason is that whatever the uranium is there, it will be simply leaching out from the what you call the rocks face into the soil phase. Okay, and soil phase into the water phase, it's leaching out very easily. Okay, and presently we are drinking most of the time around 40 to 60% we are drinking from the groundwater only. Okay, only few percentage we are drinking the surface water. So that is very much important. Actually, in the present study, we are just calculate the physicochemical parameter, the measurement of the uranium, and cancer risk assessment, and regional variation, and seasonal variation also. So this is the sampling location of Chikkballapura district, one of the main district in South Karnataka. Okay, that is consists of many places like Nandi Hills, okay, Isha Foundation, and our Kempegowda International Airport. Many places come together then. Okay, after complete study of geological studies, okay, we done it around 27 samples. Okay, that is from the as well as ponds, as well as in what you called bore wells. Okay, in both the locations we took it water samples. That is also based on the geological parameters. We take it and you study that. Okay, So this is the materials and methods. In materials and methods, we carried out the measurement of the uranium in Kerala, Mangalore University, okay, and we collected 27 samples, and all the samples we brought it into the Mangalore University, okay, and we took it into the treatment, and we just filtered with 110 micrometer Wattman filter paper, then take it into the LED fluorimeter, okay. So, and we calculated excess lifetime cancer risk and lifetime average daily dose and hazard quotient also. And this is the results, okay. This is the uranium concentration in well water samples, okay. I had given the different sample numbers, okay. And a few of the samples, okay, below the average, and in few samples like K3, K13 and K19 and 21, okay, which is above the whatever the WHO and IARP permissible it, okay, like 600 ppb and 1600 ppb, okay, and 500, 400 ppb. And these are some results from the uranium concentration in pond water samples. But in pond water, most of the samples would show very low value. But in only some post monsoon, okay, we got it very high result around 450 ppb. And in location number K4, we got it around 100 and 125, okay, ppb. And these are the statistical results in bore well water samples as well as the pond water samples, okay. In standard deviation, which is showing around 440, 444 and 27.2 and 126.1, because of the in post monsoon pond water sample of the maximum value got it at one particular location, and skewness and kurtosis values also, it indicating that most of the positive values only. The reason is very simple here. See, only one locations, okay, one or two locations, we got it around more than 500 or more than 1500 ppb we are observing in both pre-monsoon as well as the post-monsoon season, okay. And other all the samples, whatever the samples, we took it around 27. In 27, both borewell water as well as the pond water, it will come around 11 samples, 12 samples, or less than 500 becquerel. Okay, that is the reason all the values are just showing in skewness and kurtosis values are positive values. And this is what the results of that one, okay. In extreme variation, in K13 shows that highest concentration, that is around 1606 ppb in monsoon, as well as in both 1614 ppb in winter, okay, that is around 40.8 becquerel per liter, okay. In for K14 also, it exhibits sharp increase, okay, so from 7.3 ppb in monsoon and 450 ppb. This may be reason is that from pre-monsoon to post-monsoon, there is a migration of or leaching out of the uranium, or sometime in post-monsoon also. This year we got it so many rainies, okay, that may be the reason, okay. And in groundwater and surface water comparison, when you are comparing the groundwater samples and the surface water, most of the groundwater samples are showing higher uranium concentration than the surface water, okay. And this may be due to increased O-stack interaction and geogenic contamination and fertilizer users in deeper groundwater. And depth also matters in terms of groundwater contamination, because the average depth in around Chikbalapura district, as per the groundwater report, that is 450 meters, okay, sorry, square feet, feet, okay. And geological influences. In geological influences, uranium levels vary for across location because of the granite-rich terrain are there, okay. And yeah, that is what which exhibits in uranium concentration, okay. That is the mean uranium concentration in monsoon, we got it 135.7 and winter 145.5 ppb, okay. And health and environmental concern, okay, as per the WHO and IARP recommended is 30 ppb and 60 ppb, but in many locations like K13, K3 and K14, it indicate higher excess lifetime cancer risk and higher the mitigation value. And this is what the overall analysis, okay. High conductivity, we done the conductivity value, TDS values and all the things, okay. And this is what indicating in Timmapanelli and Machielli and Dibrale and Inmanchinalli, okay. And all these locations where exactly lower uranium concentration is there, in that side it shows high conductivity despite low uranium level. And in materially that one shows high uranium as well as the conductivity is high because of the granitic influence and high uranium concentration as well as the but low conductivity value, okay, in imminently, and this was low conductivity as well as the low uranium concentration, okay, and few samples it shows below the standard permissible limit. And this is what the conclusion. Seasonal changes in uranium concentration were observed in the study area. Average values of uranium concentration is completely increased in winter season as compared to the this one rainy season, and excess lifetime cancer risk, which is major concern. And uranium concentration was found high in groundwater sample as compared to the surface water, means pond water, and uranium concentration is non-uniformly distributed throughout all the location. That may be major reason is that geological differences, and yeah, different approaches like nanofilters, line softening, and ion exchange, and reverse osmosis that may be possible to reduce the uranium concentration or from the water samples. And these are the references we took it. And acknowledgement, I am very thankful to management, BMS College of Engineering, providing OOD to come here, and Dr. Karnakara, Professor Kerar, for extending his LED fluorimeter facility to carry out this particular research work. Thank you.
Thank you, Dr. Kali Prasad, for sticking to your time. But your result seems to be slightly high on some of the samples, like 1600 ppb, what you have mentioned.
Yes, sir.
Have you cross-checked with other analytical techniques,
sir,
or repeated the things?
So recently only we done it, okay, all the samples we done it around in December only, okay. After carried out this one, directly I put it in this conference only.
No,
okay.
no, whenever you get this type of values,
okay,
it's essential that you cross-check with nearby samples also. Because bore wells are basically underground systems which are interconnected.
Okay.
So nearby location should also show these type of values.
Okay, sir.
It's it almost looks to be very impossible to have such type of values.
Sure, sir. We will try to collect more samples in that particular location and we will do it.
Yeah, before you go for any journal publication,
yeah, sure.
Please be
Sure.
assured that this is tested, revalidated.
Sure, sir.
And making very bold statements of cancer, etc. is not good at this right stage.
Sure.
So that's my opening remark. If somebody want to add on this, so we have a huge expertise of people working on uranium. If somebody would like to comment on it, I think we'll take 1 or 2 extra minutes for this topic.
Yeah, sure.
Yeah,
sir.
please. Yeah, please. Dr. Pramila.
Kali Prasad, I would like to know, you were talking about the health status of the people. Have you, are you aware any issues because of drinking high concentration uranium water?
Madam, we try to get it some research journals related to health issues in that particular area, especially in Bangalore and Chikbalapura and Dodbalapura. The cancer patients are more, especially lung cancer, okay, and cancer in abdominal cancer patients are more. Okay, in Bangalore region itself, around 10,000 members are there. Okay.
So drinking water will lead to lung cancer?
No. In abdominal cancer also is there. Lung cancer, most of the time we are telling that one smoking, it may be. Okay, we are working on to that one also.
See, that is what, no, what will be the excessive cancer risk? What you have calculated?
Which one?
You said no, the excessive cancer risk is high. And
I calculated all the data because I didn't put it here.
I don't know. See, such type of things should not be written in paper
until
unless you confirm.
Speculated, not doing
No.
anything.
We calculated, sir. But because of this time schedule, I didn't put it. Okay.
This sends a very wrong message, no? There are uranium concentration higher than this, and nobody has indicated such things in paper. So half-baked knowledge, I feel, is quite dangerous. You should see the studies. How many samples you have done in the bore well? Repeatability of your sample concentration?
14 samples were collected from
in the same sample?
No, within that.
No, I want to say single bore well, how many samples you have collected and what is the range for that sample and your standard deviation for that?
It requires some detailed analysis, I think.
That is
we will do that.
Yeah. So please do, repeat the things. So I think we'll stop this conversation, but I think it requires some detailed analysis before you publish all this. Thank you.
Thank you.
I think we'll go to next speaker, Samata from Bharatiya University. Yeah, she's there.
Good evening all. Today's presentation is on principal component analysis on computer tomography images for enhancement, image diagnosis and detections. I am Samta from Bharather University. I'll be explaining about the principal component analysis, its potential benefits and how it is uses in detecting PCA using CT images. So the reason why I took for PCA, that is unsupervised machine learning, is normally everyone goes to machine learning, which makes us real-time imaging, and it helps to eradicate the human errors, that is little errors. So the reason behind this detection is for focusing on potential enhancement for disease detection and diagnosis. This PCA helps in reducing the dimensionality reduction. That is, we'll be getting the results with great results without the loss of data. So this usually simplifies our data, complex data into smaller, and this will be helping us for visualizing images. So this feature extraction usually helps for getting the more images, that helps for distinguish for tissues, normal tissues and abnormal tissues. So this enhanced contrast will usually helps to enhances the contrast, like neglecting the signal to noise ratio. This helps for better understanding. And early detection usually contributes for potentially leading for better outcomes for the treatment and improved sensitivity. This will be getting errors in tissue density. That tissue density errors can be neglected using the improved sensitivity. So basically there are different types of machine learnings. Usually the most commonly used machine learnings are R programming language and Python. I prefer under the personal preference, I have chosen for R programming language because it is widely used around everywhere for statistical analysis. And this R programming language contains the libraries like EBI that is used for image analyzation. So there are three types of machine learning. One is supervised machine learning, another unsupervised, and then reinforcement. In this, I have chosen supervised machine learning and unsupervised machine learning. The principal analyze component usually comes under unsupervised machine learning, and then I have gone through the supervised machine learning that contains random forest error, random forest support machine vector, and KNN, K nearest neighbors. And this interpolation I have done for findings of abnormal and normal, that is benign and malignant. So in the first, in the result and discussion part, it's like I have chosen the data of CT images of a single patient that contains of 100 images. Then I'll be making this images, the normal images I'll be getting is DICOM. That DICOM images I'll be converting into JPG form, and then I'll go for the processing of image processing. In that, the contrast will be enhanced, and the images will be making into the reformation, like making the images to the dimension that I needed. And then I'll be going for a PCA, principal component analysis. This will be helping us to detect the benign and malignant part and the loss of I'll be neglecting the unwanted data. In the visualization, I'll be going for the supervised machine learning. In that supervised machine learning, we can visualize the separate plots of benign and malignant, and this clustering part exists like the similar groups will be engaged in one part and another will be in another part. So it is easy to differentiate that malignant and benign tissues. So like when I'm going for the random forest support vector machine and KNN, my accuracy level was 95% compared to the normal traditional level. And then combining the PCA and the supervised machine learning, this helped me to enhance the classification task easier. First, I was like taking only the PCA for analyzation. That time I'll be not getting that accuracy was like only 60 to 80%. Then I have incorporated the supervised machine learning to improve my sensitivity level. So this made me for high accuracy in the detection, and this will be effectiveness in real world applications. And then clinical application, it was like improved results from the previous researchers. So, and the conclusion of this presentation is of that the PCA helped me to find the scattered parts of benign and malignant, and that supervised machine learning helped me to distinguish the benign and malignant separately without overlapping, and this helped me to understand the percentage also. And the future outcomes of my projects will be on making that CT images more effective in clinical sites, and I'll be trying to make it improvement for the diagnostic purposes. And this machine learning can be made automatically for minimizing the errors, and trying to find a standard protocol for machine learning using PCA and random forest array. Thank you.
Thank you, Ms. Samta, for completing the presentation in given time.
Thank you, sir.
We use principal component analysis in basically source apportionment studies of air particulate matter. And it's nice to see that you are using PCA for CT analysis. But there we have multiple variables, 4 or 5 variables, or what we call as signatures or tracers, which
yes,
move together, then they form a cluster, and then we identify the likely sources. But in case of your CT scan, what are the variables available to you?
Sir, I took the variables I used only 3. That is benign, malignant, and normal tissues. I was just clustering those parts and making it
so
to the
benign, malignant, and
normal tissues. Like I
what I'm asking, what you see in the CT scan? What is the variable you have to study the mathematical variation?
So I didn't start it, sir. Just now I'm processing into that machine learning. Those images were also not from the hospital.
Image you have to extract something. Some difference you have to study. What do you study in that?
See,
one is you get a CT scan from malign, one you get from normal. But what you study in the CT scan?
Like only differentiating now, and the preliminary studies differentiating benign and malignant alone, sir.
Okay. The session is open for some discussion if the question. You can have 1 or 2 if it is there. Yes, somebody from the back.
Hi. You have gone for KNN, right? Why haven't we gone for logistic regression or linear regressions? Because those are the basic ones, right? You mentioned that you have gone for KNNs.
Yeah.
Why haven't you tried it with logistic regression or linear regressions?
I was like, this was easy when I'm compared to those things, and this accuracy was higher than compared to that. Then that's the reason I did not use those things.
And what about the data which are the outliers there on your scatter plot?
Oh, I can't understand. Come again?
You have got some outliers in your scatter plot, right? Have you considered them as well? Because this is a major concern, right? Cancer we are studying, or the tumor which we are studying. You have got some outliers there. So have you got any condition for clustering them separately, or you have just...
I have used only packages for clustering, like DB, scan, for those for clustering, nothing then.
So outliers you have completely left?
Yeah.
Thank you.
I'll thank Ms. Samta again for her presentation. The next presentation is by Ms. Varshita on surface contamination clearance levels for metal wastes and uranium contamination.
Hello. Hello, good afternoon everyone. I am Varshita, I'm working in BRC Mysore. Today I will talk about surface contamination clearance levels for metal waste with uranium contamination. What is clearance level is? Clearance level is basically the residual amount of radioactivity that can be present in material before we can, when we are releasing from the regulatory control, the amount of residual radioactivity present in that should be below the clearance level. Usually clearance level is specified in terms of activity concentration in becquerel per gram, or sometimes in terms of surface contamination level in becquerel per centimeter square. Now, why we need clearances? Usually when during operation of nuclear facility or during decommissioning, large amount of material will be produced as waste, which will include metals and other debris, building debris, everything will be produced, and it will contain a slight amount of radioactivity or sometimes no radioactivity, some part of it. So we cannot dispose everything as radioactive waste, because then it's not economically sound or it's not environmentally sustainable. So if we have a if we can clear the material from the regulatory control, then when we can reduce the amount of waste which we are disposing of. So we need to have clearance level. This clearance level, there are two clearance level: generic clearance level and specific clearance. In generic clearance, we are doing unrestricted release of scrap material. I mean, we will not have any restriction on the material form, type, and whether it will be reused or recycled. It will be released to the public sphere, and anything can happen. So when we are releasing, we need to make sure that it will not cause any harm to the environment and human health. So this clearance levels are given by the regulatory bodies. In our case, it is given by BSc in this radiation protection manual. And material can be cleared. Two conditions have to be met. One is it should be according to the Schedule 1 of IAEA GSR Part 3. Along with that, there's one more condition, that for alpha activity, if alpha surface contamination is present, the transferable contamination should be less than 0.037 becquerel per centimeter square. Now, GSR Part 3 says that GSR Part 3 says that when the material is cleared from regulatory control to any individual in any reasonably foreseeable circumstances, the effective dose incurred by the individual should be of the order of 10 microsievert per year or less, and it can go up to 1 millisievert in a low probability scenario. And it has also given activity concentration limits. Activity for uranium isotopes. Here I am only talking about U-234, 235 and 238. I'm not talking about artificial isotopes. Activity concentration limit is 1 becquerel per gram. Now, when we talk about alpha contamination, alpha contaminated waste, surface contamination is also important, because if we stick to this 1 becquerel per gram limit, what happens for metal waste, which are where the contamination is only present on the surface, it will not be inside the body. This 1 becquerel per gram for a 1 centimeter thickness waste, the contamination, corresponds to a contamination of 10 becquerel per centimeter square. Now, if this surface is manipulated, like we are cleaning it or when we are cutting it, it can be released. And if the person who is handling can get, since it's an alpha waste, so inhalation dose coefficients will be quite high, so they may get high doses. So surface contamination is required, clearance level is required. And we have seen that BSc has specified 0.04 becquerel per centimeter square. But there was a recent document by IAEA released in 2023, application of General Safety Guide 18, application of concept of clearance. It says that this 0.04 becquerel per centimeter square, this is used mainly for 0.4 becquerel per centimeter square is used for low toxicity alpha radionuclides, and 0.04 used for other alpha nuclides. It should not be used for clearance, and it is frequently misused as a clearance. Those are their words. So these levels, they were actually derived for transport packages, and they were derived in 1960s using the models available at that time for a dose limit of 50 millisievert per year. So IAEA recommends that we should not use that clearance level. And if we see the European Commission and UK, they have recommended a clearance level of 1 becquerel per centimeter square. So there is some order 0.04 becquerel per centimeter square versus 1 becquerel per centimeter square. So there's a huge difference. So in this presentation, I have done some preliminary studies. So I will explain what we can do about that. So here I have used the methodology suggested by IAEA General Safety Guidelines 18. They have asked us to, we can said that we can follow the method in Radiation Protection 101 by European Commission, where they derive the surface contamination levels. So here only surface contamination before the scrap material is melted is considered, because after it is melted, it will get mixed up. So we need to look at the bulk contamination. Then we don't have to see the surface contamination. And we also have to see for reuse of the material, because this is generic clearance, unconditional clearance. So that has to be also followed. The procedure is basically for different deterministic scenarios. For unit surface contamination levels, we will see what is the dose incurred by an individual in microsievert per year, and then sorry, based on that we will derive the surface contamination level, which will give rise to 10 microsievert per year. Then the lowest value will be used as a clearance level. That is the method used by RP 101. And the decay daughter products were used, assumed that they are in secular equilibrium with the parent nucleate, these daughter products, for the calculations. And these are the different scenarios I have considered. For scrap processing, there is transport, and after transport, it can be automated processing or manual processing. Manual processing also, it can be done, the cutting of the material can be done using thermal segmenting, saw, grinder, different things, and there are different release fractions for each of these processes, and we have to see the inhalation dose, beta skin dose, external dose, all the things. Again, after clearance, sometimes from one part of a nuclear facility, we are reusing the same material in another part of a nuclear facility. There also, what will be the dose incurred by any individual, I have calculated. So different isotopes, these are the doses per year if there is a unit surface contamination, and I have estimated that the worker is processing 1 ton of material. And there are actually the European Commission calculation, what they have done, they've used very very large room sizes, and sorry, meter cube was the room size used, but I have seen Indian cases, the average room size, I have taken the Indian living room size, it's around 100 meter cube. So it may not be, since it is a generic clearance we are releasing to the public, we have to take Indian parameters. So these are the values I've got. This is for during scrap processing, and this is during reuse. And out of all the possible exposure, the maximum is obtained during grinder, when they are using grinder to cut the scrap, and it is more than, for 1 becquerel per centimeter square, it is more than 10 microsievert per year. So if we consider our limit 0.04 becquerel per centimeter square, the dose incurred is of the order of less than 10 microsievert per year. So in this study, BSc recommends a surface contamination limit of 0.037 becquerel per centimeter square, averaged over 300 centimeters square for unconditional unrestricted scrap release for alpha contaminated metal waste. But there are other European Union recommends, European Commission recommends, UK recommends around 1 becquerel per centimeter square, and the IAEA GSG part 18, they have recommended not to use that 0.4 and 0.04 becquerel per centimeter square. Therefore, I have tried to calculate the surface contamination level based on parameters which are present in Indian scenarios. And I have seen that 0.037 becquerel per centimeter square, what we are using, it is acceptable as it can result in a dose of 10 microsievert per annum in a reasonably foreseeable situation. And but averaging area, it can be increased up to 1 meter square according to the IAEA GSG 18 using this method. So averaging area, we can, if possible, we can increase it. Thank you.
Okay, thank you, Varshita. So maybe we can have one question from the audience. Okay, if there are no questions, can I just ask? So for assessing the homogeneity of the 1 meter square area, you are saying, you will be taking what type of grid for the sampling?
Sampling, it depends on the history of the material. If we are expecting that some kind of systemically we are expecting some contamination, then we can use random sampling. Otherwise, we have to use some systemic sampling and first estimate what is the homogeneity. Based on that, using limited samples, based on that, we can expand this for the other remaining samples.
Okay, thank you. Thank you, Varshita. So we can have the next presentation by Mr. Somen Sinha on a critique on criteria for notifying nuclear incident under Civil Liability for Nuclear Damage Act 2010.
A very good evening to all of you. My topic is a bit different here, but I'll try to do justice to what study we have done in IARP. It's a critique actually on the criteria for notifying nuclear incident under Civil Liability for Nuclear Damage Act 2010. Basically, when we say liability, it's actually a legal liability arising for an act of commission or an omission. And in the international scenarios, we have various conventions dealing with liability, specifically nuclear liability. We have the Paris Conventions in the year 1960, supported by, later revised by Brussels Convention. Parallelly, we had the Vienna Conventions. We also have the Convention on Complementary Compensation. Basically, all these conventions dealing with liability regimes have common principles. They are exclusively liability for the operator, which is a legal channeling of the liability, strict no fault liability based principles. There is a capping on the liability amount. It is mandatory, there should be a mandatory financial coverage. The liability is limited in time, the liability is limited in space. The compensation, it has to be compensated, and there has to be special courts dealing with the liabilities jurisdictions claims. With respect to India, India has signed the compensation on supplementary compensation in the year 2010 and ratified it in 2016. Meanwhile, after signing, the requirement is that we have to have a national law to enact the provisions of the International Convention which India signs. So Article 253 of Constitution of India empowers the Parliament to make law on it, and The civil liability for nuclear damage bill was introduced in August 2010, which was debated in the parliament, and it got assented from Honorable President and became the act of the law, act of the land. What does this act now say? The Civil Liability for Nuclear Damage Act defines what is called nuclear damage. It says the loss of life or injury to a person or loss of or damage to property caused by a nuclear incident, economic loss arising out of such damage to person or property, costs of measure to repair the damage caused to the environment, and cost of preventive measures. Basically, now the operator's liability is capped at rupees 1,500 crores, and above that up to 300 special drawing rights has to be paid by the Government of India. However, a nuclear incident, a claim cannot be made until and unless the nuclear incident is notified by Atomic Energy Regulatory Board. The IARP has to notify the nuclear incident within 15 days from the date of the nuclear incident occurring, provided that if IARP is satisfied that the gravity of threat and risk involved in a nuclear incident is insignificant, it shall not be required to notify such incident. So now this provision was immediately challenged in Ernakulam High Court, saying that giving a body with such powers is unconstitutional. And meanwhile, the job on IARP was to immediately come out with a criteria for notifying the criteria on which nuclear incident will be notified. It has to be transparently told to the public, and the civil liability nuclear rules says that all such events has to be reported to IARP. So two sets of, hence for this critique, the materials and methods used were all the parliamentary debates but studied, the CLND acts and rules, the USNRC's, that is US Nuclear Regulatory Commission's criteria for defining extraordinary nuclear events occurrence were studied, the internal debates of IARP's discussions at that time were all analyzed. IARP has come out with two sets of criteria. One is called the reporting criteria, the other is the notifying criteria. The reporting criteria is to encourage the utilities to report any extraordinary nuclear event to IARP, which will be internally debated within IARP to come out with a criteria. If it satisfies the notifying criteria, it will be notified as a nuclear incident within 15 days of the occurrence, so that a claimant can submit his claims for compensation. As it can be seen, the reporting criteria says, first point was 500 times or more of iodine 131 equivalent annual release limit prescribed in tech specs, or off-site public dose of 1 millisievert, or actual injury or death of a person off-site due to the exposure to radiation, event which requires off-site evacuation, or 1000 becquerel per square meter of alpha surface contamination of 100 square meters of off-site property, or radiation level of 100 microgram 1 mR per hour. This was the reporting criteria. An order, 10 times more order was for the notifying criteria. A release of 1000 terabecquerel of iodine 131 equivalent or more, off-site public dose of 100 millisievert per event, injury or death of a person off-site due to exposure to ionizing radiation, an event requiring off-site evacuation from considering the economic loss, and 10,000 becquerel per meter square of surface contamination averaged over 100 square meters of off-site property, or radiation level of 100 microgram per hour. Now, what was the basis for having this? For this, immediately what IARP did was we took out the tech spec limits for various nuclear power plants, and considering Madras Atomic Power Station MAPS, which had the highest public dose considering argon 41 releases, etc. The tech spec limit, it was found that 500 times of the tech spec limit, that is 3.7 into 10 power 2 terabecquerel per year, would give rise to a dose of the order of 1 millisievert. So reporting criteria was considered to be 500 times of the tech spec for the purpose of reporting to IARP. And any event requiring evacuation, because the nuclear damage defines economic loss to be considered for the purpose of the claimants. So it was considered as one of the factor for the reporting criteria, and radiation level of 1 mR per hour was selected based on off-site emergency declaration, which was as per that time EPR. what was the notifying criteria? The notifying criteria of 1000 terabecquerel of iodine-131 can lead to a whole body dose of 100 millisievert. So the basic criteria which was kept for notifying a nuclear incident under CLND is 100 millisievert. So it was seen that from the tech specs, as I calculated that 500 times of tech specs, so 1000 terabecquerel of iodine-131 equivalent can lead to 100 millisievert. And 10 times of the reporting criteria for alpha contamination for derived surface contamination was considered for notifying nuclear incident, and the dose rate of 10 times of 1 mR per hour was the basis for declaration of the off-site emergency. These were the basis for the notifying criteria. So now when these were analyzed and revisited, a need was felt that okay, the criteria specified by IARP in 2013 were based on the prevalent radiation protection concepts and emergency response actions. In view of the evolved emergency preparedness and response framework, emergent technologies, these criteria may need to be revisited and revalidated. So it was again revisited in IARP, and it was found that okay, the 100 millisievert criteria holds good even today, but the extrapolation, linear extrapolation for reporting criteria, that is 500 times the tech specs of 1000 terabecquerel leading to 100 millisievert, may need a revisit, and a preliminary estimate using PC COSIMA tools showed around 7000 terabecquerel. Again, this was from the stack release. Now, considering the same as a ground level release, the orders comes to 1500 terabecquerel. EPP and EPR were updated as per IAS GSR Part 7 based on the Fukushima accident feedback. The consistency now has to be ensured with the operational OILs, the operational intervention levels, and the criteria used for notifying. It is seen that more or less it is consistent, but then while two better fits in. And economic loss not only from evacuation but also considering food ban or other measures may also be needs to be factored in. Thank you.
Thanks, Oman, for making your presentation within the given time. Thanks for informing about this new act and other things about the Civil Liability Act for nuclear damage. I think it may invoke some questions from the audience. So it's open for discussion. Sudhir.
So item number 8, this 100 microgram per hour, which is not equal to 1 mR per hour.
No, it's a typo, sir. I read it correctly. It's a typo.
So, I mean, very good information you have given to us. Can you tell what should be done in between reporting criteria to notifying criteria? There is a vast difference. Once is you are reporting and then you are notifying.
Yeah, there is a 15 days gap within which ARB has to notify.
Okay.
So once the criteria which has been given in the form of SOP is that once the ESL evaluates and gives the data back to ARB as a reporting criteria, internal committee will be formed to evaluate whether this fits for a notifying criteria. It qualifies as a notifying criteria, and if it qualifies as a notifying criteria, within 7 days the board meeting of ARB will be convened, and it will be then publicized in the Gazette of India. So all this has to be done in the 7 days.
So that is okay. Now you have given certain criteria for reporting, no?
Yeah, no,
So-
the same event, reporting criteria, the report search, and then we see whether it qualifies for the
Sure,
nuclear
no.
incident.
Okay. Okay, clear. Thank you.
More questions? See, if no more questions, we thank the speaker. Thank you very much, Somen. So we are almost at the end of the session. So we started this conference with a welcome from Mangalore University. So I think we'll end the session with an invited talk from Professor Karunakara. I don't think he needs an introduction. Still, I will request Dr. Vandana to introduce Professor Karunakara.
So, Professor N. Karunakara is Coordinator, Center for the Advanced Research in Environmental Radioactivity, CARER, and Medical Physics Division of Mangalore University. His research areas include radiation protection, environmental radioactivity, radio ecology, and nuclear safety. Development of new methods, techniques, or technology for the measurement and mitigation of radioactivity in the environment and workplace. Accelerator mass spectrometry, gamma spectrometry, liquid scintillation spectrometry, alpha spectrometry, and neutron activation analysis. Application of natural and anthropogenic radionuclides for studying environment such as soil erosion, sedimentation rate, and transportation measurements. Atmospheric mixing studies, submarine water discharge, etc. So we have Professor Karnakara, who has interest in the wide gamut of applications of radioactivity. So we invite Dr. Professor Karnakara for his presentation.
Experience he must be having watched large number of slides. We'll request you to limit to 25 minutes.
Yes.
Thank you.
Yes. Good afternoon, everybody. So I'm very happy to welcome you and also say bye-bye to you. And so I put in a word update on carbon-14 studies because in the previous IARP, the part of this talk was presented. And subsequently, we had some additional work carried out in carbon-14 measurements around the nuclear power plant in Kaiga. So, unlike other radionuclides which we normally measure in the environmental matrices, carbon-14 is the one which we very rarely measured. So, hence because of this, I thought I should give some introduction about what is carbon-14 and what is the sources of production in the environment and what are the anthropogenical sources. The carbon-14 is produced naturally in the environment because of the spallation reaction of the interaction of the neutrons produced from the spallation reactions with the atmospheric nitrogen, and that the carbon-14 such produced will combine with the oxygen to produce carbon dioxide. And this carbon dioxide, whether it is a C14O2 or CO2, the environmental matrices, these living matrices will not distinguish between whether it is radioactive carbon dioxide or normal carbon dioxide. So it will absorb the carbon dioxide, the carbon-14 dioxide, and a sort of equilibrium is reached between the environmental matrices. So in a clean area, when I say clean area, a region where there is no anthropogenical sources present, if you measure the carbon-14 activity, the activity in the atmosphere and the activity in the environmental matrices should be same, specific activity, when I say specific activity. So 1 in 10 to the power of 12, that is 1 in trillion carbon-14 atom is radioactive. That's 1 in trillion. The carbon as of today, 99% is of carbon-12 and 1% is carbon-13 and 10 to the power of minus 10% is carbon-14. The specific activity of this radioisotope is 226 kilogram per kg of carbon. That is with the reference year 1950. Why this reference year 1950? Because 1950 up to 1950 we consider there was no anthropogenical sources in the environment. So in the 1950 there was huge number of nuclear weapon tests that released huge quantity of carbon-14 into the environment, and the equilibrium got disturbed. So the one important difference between carbon-14 and other radioisotopes in the environment is the other radionuclide concentration may vary from region to region, but whereas carbon-14 it remains constant if the region is not affected by anthropogenic activity. So 226 becquerel per kg carbon is we call as the reference value in the year 1950. So that's how the application of carbon-14 is used in the dating applications. The units used is also quite different from that of other radioactivity radionuclide measurement. Here we use the specific activity, that is becquerel per kg of carbon or percentage of modern carbon with 1950 as the reference date. or it is also quantified in terms of fraction modern carbon, F14C, which is the ratio of activity as on date to that of activity as on 1950. So, if you look at the variation of carbon-14 in the atmospheric carbon dioxide since 1950 to the present day, you will see that this concentration was in the year 1950, this fraction modern carbon, if you take it as 1 in the year 1950, suddenly it increased over the next decade. That is because of the nuclear weapon test, which released huge quantity of carbon product. And by 1965 or so, this the fraction modern carbon, that value increased, is almost doubled. And in terms of activity, specific activity, 226 became almost 452. So then there was a nuclear test ban treaty, and because of that, there was no additional input of carbon dioxide, carbon-14 into the environment, and the levels have subsequently decreased. And that is because since there is no anthropogenic input, the weapon-derived carbon-14 got absorbed in the ocean or got dumped in the ocean, and also subsequent the increase in the use of fossil fuels. So fossil fuel has dead carbon. So if you take petroleum products, you have zero specific activity of carbon-14. That's what one of my student Arya was talking about. That is the basic principle of quantification of adulterated product and the natural product. If you measure it in a natural product, it will be 226 becquerel per kg. Whereas in the adulterated product, petroleum product, adulterated product, it will be less than that. So because of the increased use of fossil fuel, that also contribute for this. But as on date, if you measure, it has come back to about 227 becquerel per kg of carbon. And this lowered this effect is also known as stress effect. And as on today, if you talk about, because there is nuclear weapon testing in the atmosphere, and the nuclear power plants also can generate and release certain quantity of carbon-14 into the environment. And in nuclear reactor, the carbon-14 is produced because of the interaction, this neutron index reaction with O17, nitrogen-14 and carbon-13. And relative abundances and fission cross-sections are given here. And the carbon-14 production occurs in coolant, moderator, and in the fuel cladding and structural materials. So whatever produced in the coolant and moderator is partly released to the environment and through the air and water route, and whereas in the fuel and fuel cladding structural material produced carbon-14s are partly released into the environment during fuel reprocessing. So what is the need of carbon-14 measurement? So it has a long half-life and highly mobile and assimilation into the environment matrices. The metabolism of carbon-14 follows that of ordinary carbon, that is carbon dioxide, enters many components of human tissue. Carbon-14 monitoring the environment matrices in the vicinity of NPP in some of the developed countries has been carried out. Others are now implementing. There is an argument. So those countries which have not started carbon-14 measurement, carbon-14 measurement, or they have not included this radionuclide measurement in their routine monitoring program, have argued that measurement of carbon-14 is not important. And that is because they think that natural global inventory of carbon-14 is about 300 million curie in the biosphere, and that is mostly in the ocean. Nuclear weapon testing added about 9.6 million curie, which is about 3% of the natural inventory. So what the argument is, the total global inventory had been used in the past to argue that power plant emissions would be insignificant. Primarily, the reason why it is not being included in the routine environmental monitoring programs. But we can, to this argument, we can do a simple calculation, and we can really find out whether this argument is really correct or not. So what you can do is you can assume an area of interest of about 5 kilometers within the nuclear power plant, and you can take about 300 meters of atmospheric column. And you calculate the volume of in this area, and this turns out to be about 2.4 into 10 to the power of 10 meter cube. With a carbon-14 content of in the that is natural carbon-14 content of about 0.044 becquerel per meter cube in the air, atmospheric inventory in that volume is about 1.073 becquerel, gigabecquerel. Whereas a nuclear power plant, say for example about 500 megawatt electrical capacity, will release about 300 gigabecquerel per year. That is about 10 curie per year. So if you consider that value for a global inventory, it is negligible. But for the local region, if you consider, it is not insignificant. It is really significant. So you will see that you are adding 370 gigabecquerel to 1 becquerel. So it is a huge addition in the local vicinity of the nuclear power plant. And you can also similarly do another calculation for the radioactivity, carbon-14 constant activity in the plant, in the plants around the nuclear power plant. So you can see that if you do the calculation, the inventory because of the natural carbon-14 in the plants in the region turns out to be about 7.77 gigabecquerel per year. That is about 0.21 curie. But if you say, as I said, at 370 gigabecquerel per year release per year, that is about 10 kilocurie, you compare. So that being the case, see that if you consider a small region, this release is not insignificant. Hence, there is a need to monitor this radioisotope. So for a small region, for example, this collective dose, if you calculate, if the nuclear power plant is opening in a region where the population is large, then this becomes really significant. So when we started this study in the 2015, our objective was to develop a method for carbon-14 measurement in the atmospheric environment and the terrestrial environment and the freshwater and marine environment. Develop the method and then establish a database for the nuclear power plant of Kaiga, and then assess the radiation dose due to this radioisotope, and that is because of the excess activity. When I say excess activity, over and above 226 becquerel per kg of carbon. So we were successful in that the objectives. We developed methods in CARER for the measurement of stack effluent, stack effluent measurement, ambient air measurement, and biota, terrestrial biota measurements. So I need not touch upon the methods. We developed methods based on the pyrolysis of the sample using the pyrolyzer system. This is nothing but a thermal combustion system. And we know we could achieve a high degree of precision in the measurement and the accuracy in the measurement. And this is the data which is showing the repeatability of the measurement for many number of samples. We took the IAEA reference value, reference material, which has a carbon-14 specific activity of 293 becquerel per kg, and you see that the high degree of precision and accuracy we could achieve from the method we have standardized. Similarly, the method was also capable of measuring levels of carbon-14, which is extremely low when compared to the natural levels. For example, we analyzed a IAEA reference material which is called C5 wood, which has a specific activity of 52 becquerel per kg of carbon, and you can see that the repeatability of our measurement for such a low level of radioactive carbon-14 specific activity in the sample. And this is a comparison of the method, the achievements of our method when compared to those reported in the other parts of the world. Yesterday there was a question from one of our delegates that what is the MDL value of our liquid scintillation method. I have given that here. You can see that the third column we have achieved a MDL level of 13 becquerel per kg of carbon for 300 minutes of counting, and 7 becquerel per kg of carbon for 1000 minimum minutes of counting. And this value, if you compare to the others, you take the most modern labs in the world, we are on par or on slightly better. These publications are available in the journals. You could very well see that, and some of the other publications. And similarly, we measure the, developed methods for the measurement of carbon-14 release from the nuclear power plant, both in oxide and reduced forms. And for the first time, a large database was established for an operating nuclear power plant, and that is the Kaiga nuclear power plant. And we established the database for both oxide and reduced forms of the release rates of carbon-14. So you could see that this is where Kaiga is situated, and that is the Kaiga Valley and the nuclear power plant, where it is situated. And a large database was generated, as I said before, 500 samples, about 500 samples by LSE measurements, and validation by AMS measurement by, with about 100 samples. A reliable database was established. So this is the database for, the release of carbon-14 from the nuclear power plant, both in the oxide carbon-14 from the nuclear power plant for the 5 years. You could see that, the release rate is, extremely small, about 2.2. In the year 2017, it is about 0.24 terabecquerel per gigawatt per annum. And in the year 2020, the release rate was on the order of magnitude higher. And again, and in the 2022, it was again back to the normal levels. So you may immediately ask a question, why in 2020 the release rate is high? So in that year, when we measured, the ion exchange column was in the extended period of operation, and subsequently that ion exchange column was replaced, and immediately the release rate came back to the original levels. And this is the quantification of oxide and reduced form of carbon-14 release, and you see that the percentage of reduced form is about less than 1%, is about 1%. So you see that from a pH power plant, the major component of release is through oxide form. And this is the comparison of release rate for Kaiga region, Kaiga nuclear power plant with those reported for RAPS. You see that the emission from Kaiga is much lower than that reported for RAPS. Of course, you should keep it in mind that we are talking about year 2020. This is the data for 1980, when now the technology has improved vastly, and then that is reflected in this data. A comparison of the data for Kaiga region with those reported for other parts of the world as well as RAPS. You can see that again, Kaiga is this is the normalized release rate. And the excess carbon-14 activity. When I say, as I said, the excess carbon-14 activity is the value which is over and above the atmospheric background levels. Atmospheric background level is 226 becquerel per kg of carbon, and over and above what is the levels around the Kaiga region. So you could see that the excess value in the terrestrial plants is very minimal, which is about 20 to 25 becquerel per kg of carbon, which is on par with those reported for other countries. You could see that the data which I have presented on the either side of the nuclear power plant, the center dashed line shows the place where the nuclear power plant is. That on the right side, you go away from the reactor, and this side again you go away from the reactor. So that is the locations of the monitoring are along the Kaiga Valley. And these are the values of excess activity, the carbon-14 activity for the predominant wind direction of Kaiga region. You can see that the measurements were done both during the southwesterly wind direction as well as the northwesterly wind direction. Because of the valley, Kaiga Valley, because I don't know how many of you are aware of the region of Kaiga. Kaiga, this is the Kali, situated in the Kali River Valley. The uniqueness of this region is the wind direction over the hill may be different than that of within the valley. So even though the direction in one direction, the valley direction will be different. So valley mixing and valley flow may be the reason for such observation. The observation is that the excess activity, what we have recorded along the valley on the either side, we could record up to about 10 to 15 kilometers from the nuclear power plant, particularly during the southwesterly wind. And that is because, and this is important because the majority of the reports which are given for the other parts of the world shows that excess activity is recorded up to a 5-kilometer zone. But in Kaiga, you could measure up to about 10 kilometer, 15 kilometer, because this is particularly because of the transportation of the gaseous effluents along the valley. Similarly, the activity of carbon-14 along in the atmospheric environment also calculated. Here also we find the similar levels of excess activity in the region, and same observation. The excess activity was transported to larger distance when compared to the other power plants, particularly because of the valley flow. And these were modeled using the computational fluid dynamics modeling, and we have found that there is excellent correlation between the data, measured data, as well as the data simulated by the computational fluid dynamics modeling. And this is the comparison of excess activity in the vicinity of Kaiga NPP with those reported around the world. You could see that for the clean region, the data for the 2017 was 230 becquerel per kg. As I said, in 2016-17, the atmospheric natural levels of carbon-14 was about 230. Today it has come to 227. You see that the excess activity in Kaiga region is up to 46, which is, on the lower side or on the similar levels than that reported for other parts of the world. So this is how I go back the carbon specific activity plot for the from 1950 to 2020, and you see that today this plot, the dead end of the line is where the baseline activity is, and the Kaiga value that is shown by the triangle is just above the background, and whereas those reported for other parts of the world are much higher above the baseline levels. And the annual effective dose were calculated from the carbon-14, and we calculated both in the case of using the database given for UNSCARE. One of the important component for dose calculation is the carbon intake by the person. So in UNSCARE gives the carbon intake about 72 kg per year, and whereas in Kaiga it is slightly, we did a dietary survey, and from that we find that the carbon-14 intake by the population of the Kaiga is higher because the main source of diet is rice, which has got higher carbon content. See, we calculated the dose rate, which is about 1 microsievert per year. And if you compare this dose rate which is higher when compared to other nuclides from the NPP. So this again shows that there is a need to include these radioisotopes in the routine environmental monitoring around the nuclear power plant. And one of the recent developments from our laboratory is that development of a secondary reference material for liquid, the thermal combustion and liquid scintillation counting system. There was a need because in the carbon-14, unlike other radioisotopes, there is not many reference materials available. We developed a reference material for this. We could get about a wood of about 100 years old, and these samples were subjected for several analyses of liquid scintillation counting and AMS measurement. And we have now come out with a reference value of 221.38 plus or minus 0.74, and this is the importance of this is when you do the carbon-14 measurement, the combustion property of the sample you take should be exactly similar to the samples which you are going to analyze. So reference material and the samples to be analyzed should have same combustion property. So this wood sample has the same combustion property and is a truly representative reference material for the samples we analyze in our region. And we will be very happy to share this reference material with those laboratories which are interested in getting it. And Arya has talked about this in this. This is our recent development. we applied this method which we have developed for the quantification of quantification of adulteration in various natural products, including caffeine, oils, because we know we are all fond of our beauty products, and we do not know many of us do not know that these products are sometimes adulterated. This can be exactly quantified by the carbon-14 measurement, including the wine can be quantified for the adulteration. And one very important development which we have made in a very recent is the development of a pyrolyzer system within our laboratory. So normally if you buy a pyrolyzer from outside, you pay about 90 lakh to 100 lakhs. So we have developed a pyrolyzer system with the much lower cost. This can also combust samples as efficiently as that the imported machine would do. So this pyrolyzer is also available in our laboratory. Some of you can visit this our center and see this pyrolyzer working extremely nice for the combustions of the sample. The achievements of our studies on carbon-14s are: a batch method was developed and successfully standardized, innovative, and then a user-friendly method was developed for carbon-14 measurement in gaseous effluent and atmospheric air samples. Development of a reference material is an achievement. This is the first detailed study on carbon-14 measurement in the biota samples in the offsite locations of a nuclear power plant in India. An extensive database has been established for excess carbon-14 specific activity in air, terrestrial, and aquatic biota in the vicinity of Kaiga NPP. The dose to the public due to the release of carbon-14 from the Kaiga NPP was quantified to be about 1 microsievert. The dose from the natural source is 12 microsievert per year. If you consider the dose from the reactor, due to the release from the reactor, is 1/12 of what we get from the natural, due to the natural carbon-14 in the environment. Thank you very much.
Thank you, Professor Karunakara, for a very lucid talk, almost like a tutorial. I'm sure all my ESL colleagues and other participants must have learned a lot on this subject. Just like a classroom, I think you can have 1 or 2 questions if you are interested. Yeah, Dr. Sudhir.
Sir, this collective dose concept we cannot take in this case.
Pardon?
Collective dose concept,
yeah,
we cannot take in the case of any power reactor or research reactor. Collective dose concept, if 1 crore people all putting 1 rupee each, it will get a higher figure. So it is better carbon-14, because other major radioisotopes we are taking care in case of power reactor. So no, as a research point of view, it is okay. But carbon-14 release and coordinated to collective dose, it is very difficult. That is why I told, 1 rupee, 1 crore people, it will be, that amount will be very huge. So collective dose concept itself is here we cannot apply.
Then what is your suggestion on that contest?
Means due to that carbon-14 0.1 MR per hour only, one particular person. So
no,
there
carbon-14 will not give you the gamma dose to talk. You can't quantify it in
beta
terms
dose
of MR
only 156 keV. So it is not alarming also. 1 lakh people staying there. If you add a collective dose, it is a huge figure. So that is why in research reactor or power reactor, they are taking care of other major
isotopes. But I got your point, but
not.
When I use the collective dose, it is not my words, it is the what you have get it in IAA Tech Doc.
Actually, collective dose concept we are taking into consideration to control the release and safety regulators there, instead to certain control must be there.
The dose value which I have calculated is not the collective dose.
That I know.
It is the dose to a individual due to the ingestion of carbon-14 through food. This is not 1 microsievert is not due to collective, is not the collective dose concept. This is the individual dose I am talking about.
So whatever he has shown is individual dose, 1 microsievert
No,
and
you
12
have
leads to
mentioned
12
collective dose.
microsievert.
You have mentioned collective dose
Collective
also.
dose
that
in the
is-
beginning, because when, if you in the region, when you compare to 1 terabecquerel in a region and you add 1 gigabecquerel and you add 300 gigabecquerel, then that concept of collective dose should be taken into consideration. Here, when I talk about 1 microsievert, it is not collective dose. It is dose to their individual due to the consumption
that
of
I know.
87 kg of carbon.
That I know.
Yeah.
This is the
Yeah, I got your
background
point.
level where
I got your
people
point.
staying there.
Yeah.
Thank you, sir.
Any other question? So, no more questions. Thank you very much, sir, for a nice talk. Nice and systematic talk. Systematic work.
I would like to request Dr. A. Vinod Kumar, chair of the session, to present a memento to our invited speaker, Dr. Karunakara N., as a token of appreciation. I also request Dr. A. Vinod Kumar sir to present a memento to Shri I.V. Saradi, EMAD, BARC. Also, Shri Kailas Gareth, Scientific Officer E, VARC. And to Dr. Rupali, Scientific Officer E, BARC. I request Dr. Karunakara N. to present a memento to chair of the session, Dr. Vinod Kumar. Once.
Thank you, IARP. Thank you, Appreciating Calligraphy. Thank you very much.
I request Dr. Karunakara N. to present a memento to chair of the session, Dr. A. Vinod Kumar, and co-chair Dr. Vandana Pulani, as a token of gratitude.
We have one more work to be done, that is our paper award. Is it ready now? Is it finalized? Okay. I think we'll declare and
Completed in 5 minutes. Meanwhile, I request the delegates to please, at least a few of you can come up forward and express your feelings about the conference, please.
Good evening to one and all. Myself, Dr. Ambika MR from Bangalore. We are truly indebted to Karunakara sir because our entire research group have utilized the facilities in Kerala. So on behalf of my research group of Bangalore, who is pursuing studies in environmental radioactivity and irradiation studies, we thank Karunakara sir. And then regarding IARP conference,
Yes, to say in one word, it was awesome. All 3 days, technical sessions, deliberations by different speakers, interactions, eminent scientists were here, and then hospitality, food, everything was no words to describe it. It was really awesome. And on behalf of all, I'm here to thank and congratulate the entire team, Mangalore University team, as well as IARP members for organizing this wonderful event. And thank you one and all. Sorry. Yes, Dr. Karnakar sir, he deserves a standing ovation. I request all to please raise for his contribution. Thank you one and all.
Good evening, one and all. I would like to thank you, the IARP, for giving this opportunity to speak about my experiences. This is my second time attending the IARP. The last time I have attended in the Mumbai, and this is second time in the Mangalore University. I felt this venue a great place to share the experiences of other research. I find it very useful, and compared to last time, it is even much better here. I found it. I really thank you, the organizers, especially the Karunakara sir and all other managing committee. Thank you so much.
A very good evening, all of you. Since last 3 days, we are witnessing a grand event here. We are discussing science, and it really gives us insight to work ahead, and we have very fruitful discussions. So I witnessed 2 different teams, one at Mumbai and one at Mangalore. So when we are lightened at Mangalore, we are checking in the hotel. Then daily we are coming by the bus. So these all arrangements are very perfect. So I congratulate all the organizers, on behalf of all the delegates, and especially Karunakaran sir. You are always inspiration for all of us, and not only Karunakaran sir, whoever I'm from RSSD division, HS&E groups. So whoever has been contributed, I really congratulate them, and looking forward for more such conferences. Thank you so much.
So again, a very good evening to one and all. For presenting the awards for the oral presentations, oral lectures, I request the trustees of IARP, Dr. Sanai and Dr. Patkulkar, to kindly come up on the stage and present the awards to the oral winners. And then I will be announcing the names of the winners. So I would like to inform that we had, I told earlier, we received around 250 total contributions for the conference, out of which based on the review at each and to the reviewers, whatever marks were given by the reviewers, based on that the papers were classified whether they will be presented as an oral presentation or a poster. And then even over here during the oral presentation we had 3 referees who were assessing the presentations based on different parameters. So again we take it in the spirit that all were good, but yes, there are some slight differences. So based on that we have the awards, or we have got 4 awards, which out of which 3 are instituted by IARP and 1 award is by Carer, Mangalore University. So the first award goes to oral presentation for application of in-house synthesized hydroxyapatite for uranium recovery from acidic raffinate samples by Shri Chetan B. Dusane of EMAD BARC. The second prize goes to the oral presentation on thermal oxidation and liquid scintillation counting method for the carbon-14 determination for quantifying the natural and synthetic components in bio-based products by Ms. Arya Krishnan from Carer, Mangalore University. Congrats. Thank you. So the third prize, just 1 second. I think the second prize is a tie. Third is a tie. So the third is a tie, of which one of the award goes to the topic on contamination monitors. Contamination monitors calibration systems by Athira B. Warrior from IG Car Kalpakkam. And the third prize is shared by the oral presentation on neutron fluence rate measurements in experiment canal of FBTR by Ms. Jayashti Mali of RSSD BARC. Thank you very much, sir, for honoring us by presenting the awards to the students. Now, I request Dr. Vinod Kumar to kindly felicitate our trustees by presenting them the memento for the IARP conference, 35th conference. Dr. Sanay. And to Dr. D.S. Patkulkar. Thank you, sir. So that brings us to the end of the presentation of awards. Thank you.
Sorry for intervening in between. So everybody was telling about pricing, about my leadership, my work and all. To tell you frankly, the effort I have put is minimal. Everything is run by the great young team. So I would like to present before you our entire team. They deserve a big round of applause rather than me. So I request all of you to come, this big team, including all the research scholars, guest faculties, and the students of medical physics. Please come here to the dais. We shall have a photo session now. And they really deserve the praise for the success of this conference. Please come. So you might have seen them, sir, doing all the arrangement with a smiling face. And they have, to tell you frankly, 2-3 before days I was totally tired, and I was on the verge of collapse. But these students, they did not allow the show to be stopped anyway. So they are the responsible persons, and again a big standing ovation for them. When
To conclude, we would like to thank our esteemed dignitaries, speakers, sponsors, delegates, and each member of organizing committee who has made this conference a remarkable event. With that, we officially bring this conference to a close. Thank you once again for being a part of this enriching experience. Safe travels, and we look forward to seeing you at future events. I request all the delegates to have tea